Hey guys! Tonight on Slumber Expeditions, we explore one of humanity's most persistent and haunting collective memories, the story of a catastrophic flood that appears in over 200 cultures across every inhabited continent, a deluge so profound that it may mark the boundary between two distinct chapters of human civilization. We will dive deep into the geological evidence, the ancient texts, and the scientific theories that suggest something truly cataclysmic occurred roughly 12,000 years ago, an event so devastating that it carved itself into the very DNA of human storytelling and may have erased entire civilizations from the archaeological record. Tonight's journey will take us from the cuneiform tablets of ancient Mesopotamia to the ice cores of Greenland, from flooded caves beneath the Mediterranean to submerged coastlines that once teemed with human settlements. We will examine the geological signatures of sudden sea level rise, the astronomical evidence for cosmic impacts, and the indigenous oral traditions that speak with uncanny specificity about waters rising to consume the world. So before you settle in, if you're finding comfort in these ancient catastrophe mysteries, please consider liking this video and subscribing to the channel, but only if you genuinely like what we do here. We would also love to hear from you in the comments below. Tell us where you are listening from and what time it is there. It's always fascinating to connect with a global community of curious minds who share this fascination with humanity's deepest memories. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's speculative journey together. The waters of the past are calling us back, inviting us to remember what was lost. You are standing in the ancient city of Uruk in southern Mesopotamia, approximately 4,000 years before the Common Era. The sun beats down on mud brick walls as scribes carefully press wedge-shaped marks into soft clay tablets, recording a story that was already ancient when they first heard it. Before you, a master scribe recounts the tale of Utnapishtim, a man who is warned by the god Ea of an impending deluge that would destroy all of humanity. Following divine instructions, Utnapishtim built an enormous vessel, sealed it with pitch and bitumen, and loaded it with his family, craftsmen, and the seed of all living creatures. For 6 days and 7 nights, the storm raged with such fury that even the gods cowered like dogs. The waters rose above the mountains, and all of humanity perished except those aboard the great boat. When the floods finally receded, the vessel came to rest on Mount Nimish, and Utnapishtim sent forth birds to search for dry land, first a dove, then a swallow, and finally a raven that did not return. As you listen to this ancient account, you realize you are hearing the Epic of Gilgamesh, and that this flood story predates the biblical account by more than 1,000 years, suggesting a memory so profound that it was passed down through countless generations. The Epic of Gilgamesh, discovered on 12 clay tablets in the ruins of the library of Ashurbanipal at Nineveh in the 19th century, represents only one thread in a vast tapestry of flood narratives that span the globe. The biblical account of Noah and the Ark, familiar to billions, shares remarkable structural similarities with the Mesopotamian version, including the dimensions of the vessel, the gathering of animals, the sending of birds, and the promise that such devastation would never again visit the earth. Both stories speak of divine displeasure with human corruption, of a chosen survivor tasked with preserving life, and of a covenant established in the aftermath of unprecedented destruction. The parallels are so striking that scholars have long debated whether one tradition influenced the other, or whether both draw from an even more ancient source, a true historical event so traumatic that it became the foundational catastrophe myth of Near Eastern civilization. But the flood narrative extends far beyond the ancient Near East, appearing in cultures that had no known contact with Mesopotamian or Hebrew traditions. In ancient Greece, The myth of Deucalion and Pyrrha tells of Zeus deciding to end the Bronze Age with a great flood, sparing only the virtuous Deucalion, who built a chest that floated for 9 days before coming to rest on Mount Parnassus. In Hindu tradition, the Matsya Purana recounts how Manu, the first man, was warned by a fish avatar of Vishnu about an impending flood and was instructed to build a boat to save himself, the 7 sages, and seeds of all plants. The fish then towed the boat through the raging waters until it came to rest on a mountain peak in the Himalayas. These stories, emerging from entirely separate cultural lineages, share a common architecture: divine warning, virtuous survivor, vessel construction, gathering of life, catastrophic waters, mountain refuge, and the receding of human civilization. Indigenous traditions from the Americas add further depth to this global pattern of flood remembrance. The Hopi people of the American Southwest preserve detailed oral histories of multiple worlds destroyed by water, with survivors emerging into the current world through a reed or climbing to the tops of mountains. The Lakota tradition speaks of a great flood that covered the earth when humanity became wicked, with only one girl surviving by floating on a wooden bull, eventually landing on a hilltop where an eagle came to her aid. In South America, the Inca preserved stories of a creator god who destroyed the first race of people with a flood, after which new peoples emerged from caves, springs, and lakes. The Chibcha people of Colombia told Spanish chroniclers about Bochica, a bearded prophet who appeared after a great flood had destroyed their civilization, teaching them arts and agriculture. These narratives, recorded by early ethnographers and missionaries, cannot be dismissed as biblical contamination, as many contain elements and details that predate European contact and reflect genuine indigenous cosmologies. The Australian Aboriginal peoples, whose continuous cultural presence on the continent extends back at least 65,000 years, possess flood traditions that may represent the oldest continuously transmitted stories in human history. Multiple Aboriginal groups from coastal regions describe a time when the sea level was much lower, when people walked across land that is now submerged, and when a great rising of waters forced their ancestors to retreat inland. The Yolngu people of northeastern Arnhem Land tell of how the ancestral sisters the Jangol crossed the sea from the mythical island of Barauku, which some researchers have interpreted as a memory of the flooding of the Sahul continental shelf. Similarly, the Narungga people of South Australia preserve stories of Ngurunderi pursuing his wives across a land bridge to what is now Kangaroo Island before the waters rose and separated the island from the mainland, a geological event that occurred approximately 10,000 years ago when rising seas inundated the Spencer Gulf region. Polynesian and Melanesian traditions add another layer to this pattern of global flood memory. In Hawaiian tradition, the demigod Nuyu survived a great flood by building a large vessel, and after the waters receded, he made offerings to the moon, believing it to be the god Cain who had saved him. The Maori of New Zealand tell of Tawaki, who climbed to the heavens and caused a great flood to punish humanity, with only a few people surviving on the peaks of the highest mountains. In Fiji, the story of a great deluge appears in multiple variations, often involving a god's anger and the survival of a chosen few who repopulate the earth. These Pacific traditions are particularly significant because they represent seafaring cultures whose navigation skills and oral precision regarding land, sea, and sky suggest that their flood stories may encode genuine environmental memories passed down through countless generations. The Chinese tradition preserves one of the most detailed and historically grounded flood narratives in the story of Gunyu, which appears in texts dating back to at least the 2nd millennium BCE. According to these accounts, during the reign of Emperor Yao, a catastrophic flood inundated the central plains of China, lasting for multiple generations. Gun, the father of Yu, attempted to control the floods by building dams and dikes, but failed and was executed for his incompetence. His son Yu succeeded where his father had failed, not by blocking the waters, but by dredging channels and creating waterways that drained the floodwaters back to the sea, a project that allegedly took 13 years to complete. Recent archaeological and geological studies in the Yellow River Basin have identified evidence of massive flooding events that occurred approximately 4,000 years ago, suggesting that the Gunyu narrative may preserve a genuine historical memory of catastrophic inundation, though on a regional rather than global scale. African traditions similarly preserve diverse flood narratives that resist easy categorization as biblical borrowings. The Yoruba people of West Africa tell of Obatala, who descended from heaven to create the earth on the waters of chaos, and of subsequent floods that threatened to destroy his creation. The Mbuti Pygmies of the Congo Basin preserve stories, recorded in the early 20th century, of a great flood from which only one family survived by floating in a mortar. The Mandinka of West Africa maintained oral histories of catastrophic floods that destroyed earlier civilizations, forcing survivors to flee to higher ground and rebuild their societies. These African traditions are particularly valuable because many were recorded before substantial Christian missionary influence, suggesting they represent genuine indigenous memories rather than adaptations of imported narratives. What makes this global distribution of flood stories so compelling is not merely their existence, but their consistent narrative architecture. Anthropologist Sir James George Fraser, in his exhaustive compilation, Folklore in the Old Testament, published in 1918, catalogued flood traditions from cultures spanning 6 continents and identified recurring motifs that appeared far too frequently to be coincidental. The warning received by a righteous individual, the construction of a survival vessel, the preservation of family and animals, the testing for dry land using birds, the landing on a mountain, and the covenant or promise that such catastrophe would not recur. These elements appear in varying forms across cultures separated by vast oceans and thousands of miles. Fraser's work suggested that either these stories all derived from a single source that diffused across the globe in prehistory, or they commemorated an actual event witnessed by ancestral populations before they dispersed to their current locations. The alternative explanation, long favored by skeptics, holds that flood myths are simply the universal human response to localized flooding events, that riverine civilizations naturally develop catastrophe narratives based on periodic inundations, and that the similarities between these stories reflect common psychological patterns rather than historical memory. This interpretation suggests that the great rivers that cradle early civilizations, the Tigris and Euphrates, the Nile, the Indus, the Yellow River, the Amazon, regularly flooded with devastating consequences, and that each culture independently generated explanatory narratives that took on mythological dimensions through repeated retelling. The biblical flood, according to this view, merely represents the Mesopotamian experience of catastrophic river flooding projected onto a cosmic scale with no connection to any global event. Yet this dismissal becomes increasingly difficult to sustain when we examine the specificity of certain flood traditions, particularly those from coastal and maritime cultures that describe not rivers overflowing but the sea itself rising to consume inhabited lands. The Aboriginal Australian stories are especially significant in this regard, as they describe with remarkable precision the inundation of specific coastal regions, the transformation of hills into islands, and the drowning of hunting grounds and gathering places. When these oral traditions are mapped against the geological record of post-glacial sea level rise, an extraordinary correlation emerges. The flooding of the Bass Strait between Tasmania and mainland Australia, the inundation of the Gulf of Carpentaria, the drowning of the Sahul Shelf, these events occurred between approximately 8 and 12,000 years ago Yet Aboriginal traditions preserve topographically accurate memories of these transformations that have been transmitted orally across 400 to 500 generations. The persistence of these memories challenges conventional assumptions about the durability of oral tradition. Western scholarship has typically assumed that unwritten narratives degrade rapidly, that details become garbled and contaminated within a few generations, and that any story claiming to reach back more than a few centuries must be viewed with extreme skepticism. Yet the Aboriginal Australian example demonstrates that oral traditions, when embedded within cultural practices, ceremonial contexts, and kinship obligations, can preserve accurate geographical and environmental information across timescales that seemed impossible under the old model. Linguist and geographer Patrick Nunn has documented numerous examples of Indigenous Australian stories that encode genuine memories of coastal geography from the late Pleistocene, suggesting that oral tradition, under the right cultural conditions, can be far more reliable and long-lived than previously thought. This recognition opens up new possibilities for interpreting flood narratives from other cultures. If Aboriginal Australians maintained accurate memories of sea level changes over 10,000 years, might not other coastal peoples have done the same? The submergence of Doggerland, the vast landscape that once connected Britain to continental Europe, occurred during the same post-glacial period and would have displaced thousands of people whose descendants now inhabit the British Isles and the North Sea coasts. The flooding of the Black Sea Basin, if it occurred rapidly as some researchers suggest, would have created precisely the kind of traumatic event that could generate enduring catastrophe narratives. The inundation of the Persian Gulf, which prior to about 8,000 years ago was a fertile river valley inhabited by Neolithic peoples, might have contributed to the Mesopotamian flood traditions. These were not merely abstract geological processes, but human disasters of staggering scale, involving the loss of ancestral lands, the drowning of settlements, and the forced migration of entire populations. The question then becomes not whether floods occurred, the geological evidence makes that indisputable, but whether any single catastrophic event could account for the global pattern of flood narratives, or whether we are seeing the accumulated memory of multiple regional disasters that occurred during the tumultuous period of post-glacial environmental transformation. The answer may lie in understanding the unique conditions that prevailed at the end of the last ice age, when massive ice sheets covering much of the northern hemisphere began their final collapse, when sea levels rose by more than 400 feet over several thousand years, and when the climate system lurched through a series of dramatic warming and cooling phases that would have seemed to any human observer like the very gods were at war. The Earth 12,000 years ago was a planet in the throes of profound transformation, a world poised between two climatic states, neither fully glacial nor fully interglacial, unstable and prone to sudden shifts that would reshape coastlines, alter weather patterns, and force every living thing to adapt or perish. To understand the flood narratives that echo through human culture, we must first comprehend the dramatic physical changes that characterize this pivotal moment in planetary history, changes so rapid and severe that they would inevitably have been experienced as catastrophic by the human populations who witnessed them. The Pleistocene epoch, which began approximately 2.6 million years ago, had been characterized by cyclical glacial and interglacial periods, long cold phases when ice sheets advanced and sea levels dropped, alternating with shorter warm phases when ice retreated and oceans rose. These cycles, driven by subtle variations in Earth's orbit and axial tilt known as Milankovitch cycles, typically played out over tens of thousands of years, allowing ecosystems and species to gradually adjust to changing conditions. But the transition from the last glacial maximum, which peaked approximately 21,000 years ago, to the current interglacial period known as the Holocene was anything but gradual. Multiple lines of evidence suggest that this transition was punctuated by abrupt climate events, sudden warmings and coolings, and episodes of catastrophically rapid environmental change that occurred on timescales of decades or even years rather than millennia. At the height of the last glacial maximum, ice sheets up to 2 miles thick covered Canada, Scandinavia, and large portions of northern Europe and Asia. So much water was locked up in these continental glaciers that global sea level stood approximately 400 feet lower than it does today, exposing vast areas of continental shelf that are now submerged. The coastlines of every continent looked radically different from their modern configurations. The British Isles were connected to mainland Europe by the low-lying plains of Doggerland, a rich hunting territory that may have supported significant human populations. The Persian Gulf was a river valley rather than a marine inlet, its fertile bottomlands likely occupied by Neolithic communities. The Indonesian archipelago formed part of a continuous landmass called Sundaland, linking Java, Borneo, and Sumatra to the Asian mainland. The Bering Land Bridge connected Siberia to Alaska, providing the migration route by which humans first entered the Americas. These exposed coastal plains and low-lying landscapes were not marginal territories, but prime real estate for hunter-gatherer populations. They offered abundant resources, moderate climates compared to the frigid interiors, access to both terrestrial and marine foods, and extensive networks of rivers that would have served as natural highways for travel and trade. Archaeological evidence, though necessarily limited given that these areas are now underwater, suggests that coastal zones were densely populated relative to inland regions. The few submerged prehistoric sites that have been discovered and excavated, such as the remains of settlements in the Black Sea, the Persian Gulf, and off the coast of Japan, hint at sophisticated coastal adaptations and maritime technologies that challenge conventional narratives of human cultural evolution. If these accessible coastal areas yielded evidence of such complexity, how much more might remain undiscovered in the vast, submerged landscapes of the continental shelves? The process by which these landscapes were drowned began approximately 19,000 years ago, when rising temperatures triggered the initial retreat of the great ice sheets. This retreat was not uniform or continuous, but proceeded in fits and starts, with periods of rapid melting alternating with temporary stabilizations and even brief readvances. The rate of sea level rise during this period varied considerably, with episodes of slow rise averaging a few millimeters per year punctuated by dramatic pulses when sea level jumps several meters in the span of a few centuries or even decades. These pulses, known to geologists as meltwater pulses, represent catastrophic releases of glacial meltwater into the oceans, events that would have had devastating consequences for coastal populations. Meltwater Pulse 1A, which occurred approximately 14,600 years ago, stands out as one of the most dramatic events in recent geological history. During this episode, global sea level rose between 45 and 60 feet in a period of less than 500 years, and possibly much faster. The exact mechanisms driving this extraordinary rise remain debated, but the leading hypothesis invokes the partial collapse of major ice sheets, particularly the Antarctic ice sheet and the Laurentide ice sheet covering North America. Recent research has suggested that the breakup of ice shelves and the accelerated flow of glaciers into the ocean could produce such rapid sea level changes, a finding that carries ominous implications for our current era of anthropogenic warming. For coastal populations living 14,000 years ago, this rise would have been catastrophic, advancing at rates potentially visible within a single human lifetime, drowning settlements, erasing familiar landscapes, and forcing entire communities to migrate inland. A second major pulse, Meltwater Pulse 1b, occurred around 11,500 years ago, though this event is more controversial and less well constrained by the geological evidence. Estimates of the sea level rise associated with this pulse range from a few meters to more than 20 meters, with some researchers questioning whether it represents a truly discrete event or merely a period of accelerated rise within the longer trend. Regardless of the precise magnitude, the period between 12,000 and 8,000 years ago was characterized by rates of sea level rise far exceeding anything experienced in recorded human history, with averages of 1 to 2 meters per century and potential spikes of much more during catastrophic meltwater pulses. To coastal communities, this would have manifested as the slow but inexorable advance of the sea, year after year, generation after generation, consuming beaches, salt marshes, river valleys, and eventually even the higher ground where people had sought refuge. The psychological and cultural impact of such sustained environmental stress can scarcely be imagined. Picture a coastal community occupying a river valley near the ancient shoreline, their lives organized around seasonal patterns of fishing, shellfishing, hunting, and plant gathering. Over the course of several generations, they watch as the sea creeps steadily inland, first drowning the outermost fishing camps, then the seasonal shellfish gathering sites, then the permanent settlements nearest the coast. They relocate inland, re-establish their villages, adapt their subsistence strategies, only to find that within another generation or two, the sea has caught up with them again. The memory of lost places, of graves now underwater, of sacred sites surrendered to the waves, would become embedded in oral tradition, passed down as stories of a time when the waters rose and the world was transformed. Repeat this scenario along every inhabited coastline on Earth, and you begin to understand how flood narratives could have become a universal feature of human culture. But gradual sea level rise, traumatic as it would have been, may not fully account for the dramatic character of many flood narratives, which emphasize sudden catastrophe rather than slow encroachment. This is where the specific geographical and geological contexts become crucial. In certain locations, rising sea level would have had particularly catastrophic consequences due to local topography and the presence of natural barriers that, once breached, would have allowed rapid inundation of large areas. The most famous and well-studied example is the Black Sea, which prior to approximately 7,600 years ago was a much smaller freshwater lake sitting well below the level of the Mediterranean Sea and separated from it by the narrow barrier of the Bosporus Strait. The Black Sea flood hypothesis, proposed by marine geologists William Ryan and Walter Pittman in the 1990s, suggests that when post-glacial sea level rise finally overtopped the Bosporus barrier, the resulting flow of salt water into the Black Sea basin created the largest waterfall in the history of the planet, with a flow rate potentially exceeding the combined discharge of all the world's rivers. The freshwater lake would have risen at a rate of inches per day, advancing inland by hundreds of feet per day in flat coastal areas, drowning forests that had stood for thousands of years, forcing Neolithic farming communities to flee before the advancing deluge, and creating precisely the kind of traumatic event that could generate enduring catastrophe narratives. Ryan and Pittman even suggested that this event might be the historical basis for the Mesopotamian and biblical flood stories, given that refugees from the Black Sea region could have migrated southward into Anatolia and Mesopotamia, carrying their memories of catastrophe with them. The Black Sea hypothesis has generated considerable controversy, with critics pointing to ambiguities in the geological evidence and suggesting that the transition from freshwater lake to marine basin may have been more gradual than the catastrophic scenario requires. However, recent research has tended to support at least a relatively rapid inundation, if not the apocalyptic megaflood initially proposed. Underwater archaeological surveys have discovered the preserved remains of ancient shorelines, submerged beaches, and even architectural structures beneath the Black Sea, confirming that the lake was indeed much smaller in the past and that human populations were present along its ancient coasts. Whether the flooding was sudden enough to match the dramatic accounts of the flood myths remains uncertain, but the psychological impact of watching one's homeland gradually or rapidly disappear beneath rising waters would be profound regardless of the exact timescale. Similar scenarios may have played out in other marginal marine environments around the world. The Persian Gulf, which today extends approximately 600 miles inland from the Strait of Hormuz, was during the last glacial maximum a river valley through which the combined Tigris-Euphrates-Karen river system flowed to reach the distant sea. As sea level rose during the post-glacial period, salt water progressively invaded this valley, transforming it into the shallow marine embayment we know today. Geophysical surveys of the Gulf floor have revealed the preserved topography of this ancient landscape, including the channels of tributary streams and the locations of what appear to be settlement sites, now drowned beneath 60 to 100 feet of seawater. The flooding of this valley would have displaced substantial Neolithic populations and forced them to migrate up the Mesopotamian lowlands, potentially contributing to the flood traditions that became so central to Sumerian and Akkadian mythology. The flooding of Doggerland, the landscape that once connected Britain to continental Europe, represents another massive inundation of inhabited territory. This low-lying plain, covering an area roughly equivalent to the modern United Kingdom, was not an empty wasteland but a rich hunting territory crossed by rivers, dotted with lakes, and inhabited by Mesolithic peoples whose material culture is known from occasional finds dredged up by fishing trawlers and from coastal sites in Britain and the Netherlands. The drowning of Doggerland occurred over several thousand years as sea level rose, progressively reducing the once vast plain to an archipelago of islands, then to isolated shoals, and finally to the completely submerged landscape that now forms the Dogger Bank. The final stages of this inundation may have been accelerated by the Storegga Slide, a massive submarine landslide off the coast of Norway approximately 8,200 years ago that generated a devastating tsunami. This tsunami struck the remaining low-lying areas of Doggerland and the eastern coast of Britain with waves perhaps 20 feet high, adding acute catastrophe to the chronic stress of rising sea level. These regional inundation events, dramatic as they were, unfolded within a larger context of global climate instability that characterized the transition from the Pleistocene to the Holocene. Ice core records from Greenland and Antarctica reveal that this transition was not a smooth warming but a series of abrupt climate shifts, with temperatures lurching upward and downward on timescales of decades. The Younger Dryas event, occurring approximately 12,900 to 11,700 years ago, represents a particularly dramatic example of this instability, a sudden return to near-glacial conditions that lasted for more than 1,000 years before ending as abruptly as it began. During the Younger Dryas, temperatures across the northern hemisphere dropped precipitously, glaciers re-advanced, and the climate system appeared to reset to an earlier, colder state. Then, at the end of the Younger Dryas, temperatures shot back up, possibly increasing by as much as 10 to 15 degrees Celsius in Greenland in a period of less than a decade. The cause of the Younger Dryas cooling has been intensely debated, with explanations ranging from the release of glacial meltwater into the North Atlantic disrupting ocean circulation, to volcanic eruptions, to changes in atmospheric methane concentrations. In recent years, a controversial hypothesis has emerged suggesting that the Younger Dryas was triggered by the impact of a fragmentary comet or asteroid that struck the North American ice sheet, causing widespread fires, generating a pulse of meltwater that disrupted ocean circulation, and potentially contributing to the extinction of the Pleistocene megafauna. This impact hypothesis remains contentious, with ongoing debates about the interpretation of purported impact markers such as nanodiamonds, magnetic spherules, and platinum anomalies found in sediments dating to the start of the Younger Dryas. However, the hypothesis has gained some traction in recent years as new evidence has been published and as researchers have refined their understanding of the signature left by low-altitude airbursts and impacts in ice. Whether or not a cosmic impact triggered the Younger Dryas, the event itself had profound consequences for human populations around the world. In the Near East, the cooling and drying associated with the Younger Dryas appears to have disrupted the nascent agricultural experiments of the Natufian culture, potentially serving as one of the pressures that led to the full development of farming during the subsequent warm period. In North America, the Clovis culture, characterized by distinctive stone tools and associated with the hunting of now extinct megafauna, disappears from the archaeological record at approximately the time of the Younger Dryas' onset. While the relationship between these events remains unclear, it suggests that the period around 13,000 years ago was one of significant stress and transformation for human societies. The end of the Younger Dryas, equally abrupt and even more dramatic in its warming, would have triggered accelerated melting of ice sheets, rapid rises in sea level, and the kinds of catastrophic flooding events that could easily have entered cultural memory as a great deluge. The geological record preserves a detailed archive of Earth's climatic history, written in layers of rock, ice, sediment, and the chemical signatures contained within them. For researchers attempting to reconstruct the environmental conditions that prevailed during the critical period 12,000 years ago, this archive provides multiple independent lines of evidence that can be cross-referenced and correlated to build a comprehensive picture of what actually happened. The story that emerges from this evidence is one of dramatic instability, rapid change, and periodic catastrophes that would have profoundly impacted human populations fortunate or unfortunate enough to live through them. Ice cores extracted from the Greenland ice sheet provide perhaps the most detailed and continuous record of climate change over the past 100,000 years. These cores, some reaching depths of more than 2 miles, contain annual layers of accumulated snow that can be counted like tree rings to establish precise chronologies. More importantly, the ice preserves bubbles of ancient atmosphere, allowing direct analysis of past atmospheric composition, and the isotopic ratios in the ice itself serve as proxies for temperature, revealing how conditions changed year by year and even season by season. The Greenland ice cores show with startling clarity the abrupt nature of climate change during the last deglaciation, with temperatures shifting dramatically on timescales of years to decades rather than the centuries or millennia that might be expected from gradual orbital forcing alone. The transition at the end of the Younger Dryas, visible in the Greenland ice core record as an abrupt shift in oxygen isotope ratios around 11,700 years ago, represents one of the most dramatic climate changes recorded in the geological archive. Within a span of perhaps 3 years, average temperatures in Greenland appear to have increased by 10 degrees Celsius or more, snowfall rates doubled, and atmospheric dust concentrations plummeted. This warming was not a local Greenland phenomenon but appears to have been hemispheric in scale, affecting climate systems throughout the northern hemisphere and triggering consequences that would have reverberated through ocean and atmosphere alike. The southern hemisphere shows corresponding changes in Antarctic ice cores, though with complex phasing relationships that researchers are still working to understand. The mechanism by which climate can shift so abruptly remains imperfectly understood, but most researchers invoke changes in ocean circulation, particularly the Atlantic meridional overturning circulation, commonly known as the thermohaline circulation or conveyor belt. This circulation system transports warm surface water northward from the tropics to the high latitudes of the North Atlantic, where cooling and increased salinity cause the water to sink and flow southward at depth, eventually reaching the Southern Ocean and connecting to the global circulation system. This heat transport helps maintain relatively mild climates in Europe and the North Atlantic region. When the circulation is disrupted, as may have occurred during the Younger Dryas when glacial meltwater flooded into the North Atlantic, the regional climate can cool dramatically. When the circulation resumes, as it apparently did at the end of the Younger Dryas, warming can be equally abrupt. But ocean circulation changes alone may not fully explain the rapidity and magnitude of the climate shifts recorded in the ice cores. Some researchers have suggested that positive feedbacks, self-reinforcing processes that amplify an initial change, must have been involved. For instance, the reduction of sea ice extent would lower the Earth's albedo, reflectivity, causing more solar radiation to be absorbed and accelerating warming. The thawing of permafrost could release large quantities of methane, a potent greenhouse gas, further accelerating temperature increases. The collapse of ice shelves could allow faster flow of continental glaciers into the ocean, raising sea level and potentially triggering further ice sheet instability. These feedbacks, operating in concert, could potentially drive the kind of rapid transitions observed in the paleoclimate record. Sediment cores from the ocean floor provide another crucial line of evidence about past environmental conditions. These cores, extracted from deep-sea basins around the world, contain continuous sequences of accumulated sediment that can extend back millions of years. The sediments preserve the shells of microscopic marine organisms called foraminifera, whose isotopic composition reflects the temperature and salinity of the water in which they lived. By analyzing the isotopic ratios of oxygen and carbon in these shells, researchers can reconstruct past ocean temperatures, ice volume, and ocean circulation patterns. The marine sediment record confirms the patterns seen in the ice cores: abrupt transitions, rapid sea level rise, and evidence of massive meltwater pulses that disrupted normal ocean stratification. One of the most important discoveries from marine sediment cores is the evidence for Heinrich events, massive discharges of icebergs from the Laurentide ice sheet that deposited distinctive layers of ice-rafted debris across the North Atlantic. These events, occurring roughly every 7,000 to 10,000 years during the last glacial period, involve the catastrophic collapse of portions of the ice sheet, releasing enormous volumes of icebergs and meltwater into the ocean. The icebergs carried rock and sediment scraped from the North American continent, which was deposited across the Atlantic Ocean floor as the icebergs melted, creating distinctive layers that can be recognized in sediment cores. Heinrich events were associated with major disruptions of ocean circulation and abrupt climate changes, providing a precedent for the kind of ice sheet instability that might have contributed to the flood events recorded in human mythology. The record of sea level change itself is preserved in multiple types of geological evidence. Coral reefs, which can only grow in shallow water within a narrow depth range, provide excellent markers of past sea level positions. Fossil coral terraces, now found at elevations well above modern sea level in tectonically stable regions, record higher sea level stands during previous interglacial periods. Conversely, drowned coral reefs now found at depth offshore mark lower sea level positions during glacial periods. By carefully mapping the elevations of these coral formations and dating them using uranium-thorium radiometric dating or radiocarbon methods, researchers can reconstruct the history of sea level change with considerable precision. This record shows clearly that sea level rose approximately 400 feet from the last glacial maximum to the present, with most of that rise occurring between about 19,000 and 7,000 years ago. But the coral record also reveals that this rise was not smooth and gradual. Instead, it shows evidence of the meltwater pulses discussed earlier, brief episodes when sea level jumped upward by several meters or more in geologically short time periods. Meltwater Pulse 1A, the dramatic rise occurring approximately 14,600 years ago, is particularly well documented in coral records from Tahiti, Barbados, and other locations. The rate of rise during this event, potentially as fast as 4 to 5 centimeters per year sustained over several centuries, would have been devastating to coastal populations. Even in regions with gently sloping coastal topography, this would translate to the shoreline advancing inland by several meters per year, swallowing settlements, agricultural lands, and vital coastal resources. In areas with very flat topography, river deltas, coastal plains, continental shelf margins, the advance could have been measured in tens or even hundreds of meters per year. Submerged archaeological sites provide direct evidence of human occupation in areas now underwater, confirming that these drowned landscapes were indeed inhabited and that their inundation would have affected real human populations. Off the coast of Israel, the submerged Neolithic village of Yam, dating to approximately 7,000 years ago, provides a window into life in a coastal community that was eventually abandoned and drowned as sea level continued to rise. The site preserves stone-built structures, water wells, and even evidence of ritualistic activity, including a circle of standing stones. The excellent preservation of organic materials in the marine sediments has yielded extraordinary details about the lives of the inhabitants, including evidence of the foods they ate, the diseases they suffered from, and the technologies they employed. Yam represents only one example of what must be thousands or tens of thousands of submerged prehistoric sites along the world's continental shelves, the vast majority of which remain undiscovered. In the Americas, the discovery of ancient human remains and artifacts in underwater caves and sinkholes in Florida and Mexico has pushed back the dates for human occupation and provided evidence of sophisticated adaptations to changing sea levels. The Hoyo Negro site in Mexico, where the skeleton of a young woman dated to approximately 13,000 years ago was discovered deep within a flooded cave system, demonstrates that humans were present in these now submerged environments during the terminal Pleistocene. The skeleton, nicknamed Naya, was found in a chamber that could only have been accessible when sea level was much lower and the cave system was dry. Her presence there, along with the remains of extinct megafauna that fell into the same pit, provides direct evidence of the dramatic environmental changes that transformed these landscapes from dry land to submerged cave systems. The dating of Naya coincides almost precisely with the onset of the Younger Dryas, suggesting that her story played out against the backdrop of one of the most dramatic climate events of the last ice age. The sedimentary record from lakes and wetlands provides yet another perspective on environmental change during this critical period. Lake sediments accumulate in annual or seasonal layers that can be analyzed for pollen grains, charcoal particles, chemical composition, and other indicators of environmental conditions. Pollen analysis reveals which plant species were present in the surrounding landscape and in what proportions, allowing reconstruction of past vegetation communities and, by extension, climate conditions. The pollen record from sites across North America and Europe shows dramatic vegetation changes occurring in synchrony with the climate shifts recorded in ice cores, confirming that these were not merely local phenomena but continent-wide or even global transformations. Spruce and pine forests advancing and retreating, grasslands expanding and contracting, desert vegetation replacing temperate woodlands, and vice versa. These changes document an unstable and rapidly shifting climate system. Evidence of catastrophic flooding is preserved in the geological record in the form of flood deposits, distinctive sedimentary layers characterized by poorly sorted material, erratic boulders far from their source areas, and sedimentary structures indicating rapid, high-energy deposition. The channeled scablands of eastern Washington state provide one of the most spectacular examples of catastrophic flooding preserved in the landscape. This region of deep channels, enormous gravel bars, and stripped bedrock was carved by the repeated catastrophic drainage of glacial Lake Missoula, which formed when ice dams blocked the Clark Fork River during the last glaciation. When the ice dams failed, perhaps dozens of times over several thousand years, the lake would drain catastrophically, releasing up to 500 cubic miles of water in a matter of days. The resulting floods, traveling at speeds of up to 80 miles per hour and reaching depths of hundreds of feet, scoured the landscape down to bedrock and deposited enormous gravel bars that are still visible today. Geologist J. Harlan Bretz, who first proposed this catastrophic flooding hypothesis in the 1920s, faced decades of skepticism from a geological establishment committed to uniformitarian principles, but eventually the evidence became overwhelming and his interpretation was vindicated. The Missoula floods, dramatic as they were, represented only one of many catastrophic outburst floods that occurred during deglaciation. Similar events occurred in Siberia when ice-dammed lakes drained southward into the Caspian Basin and westward into the Black Sea. The drainage of glacial Lake Agassiz, an enormous water body that formed in front of the retreating Laurentide ice sheet and at various times covered much of central Canada and the northern United States, produced multiple catastrophic outburst floods that potentially contributed to climate disruptions by dumping enormous volumes of cold freshwater into the North Atlantic or Arctic Ocean. The precise routing and timing of these outbursts remain subjects of active research, but they clearly had the potential to affect ocean circulation and trigger abrupt climate changes. Evidence for possible cosmic impacts during this period has been sought in the geological record, with mixed results. The Younger Dryas impact hypothesis proposes that a fragmentary comet or asteroid struck the Earth approximately 12,900 years ago, with impacts or airbursts occurring primarily over the North American ice sheet, but with effects felt globally. Proponents of this hypothesis point to a variety of alleged impact markers found in sediments dating to the Younger Dryas boundary, including nanodiamonds, tiny diamond crystals that can form under high-pressure, high-temperature conditions, magnetic spherules, small spherical particles rich in iron, carbon spherules, glassy carbon particles potentially formed from biomass exposed to extreme heat, and elevated concentrations of platinum group elements, which are relatively common in meteorites but rare in terrestrial rocks. They also cite evidence of widespread burning in the form of charcoal layers and burned plant remains, suggesting massive wildfires possibly triggered by the thermal pulse from atmospheric explosions. Critics of the impact hypothesis have questioned the interpretation of these markers, suggesting that many of the reported features can be explained by terrestrial processes and that some may represent analytical artifacts or misidentification of common materials. The debate has become contentious, with competing papers published challenging or defending various aspects of the hypothesis. Recent developments have tended to support at least some version of the impact hypothesis, with growing evidence for a platinum anomaly at the Younger Dryas boundary and continued discovery of what proponents interpret as impact markers. However, consensus remains elusive, and many researchers remain skeptical that a cosmic impact played any role in the Younger Dryas cooling. Regardless of whether the impact hypothesis is ultimately confirmed or refuted, it has succeeded in drawing attention to the possibility of rare catastrophic events contributing to rapid climate change and to the need for careful examination of the boundary layers between geological periods. The archaeological record from the Younger Dryas period shows evidence of cultural changes and population disruptions that may reflect environmental stress. In North America, the Clovis culture, characterized by distinctive fluted projectile points and associated with the hunting of mammoths, mastodons, and other megafauna, appears to end abruptly at or near the start of the Younger Dryas. Whether this represents an actual population crash, cultural transformation, or merely a change in tool technology remains debated, but it coincides with the extinction of numerous large mammal species across North and South America. The causes of this megafaunal extinction have been attributed variously to overhunting by humans, climate change, disease, and possible cosmic impact, with the likelihood being that multiple factors contributed. Regardless of the cause, the loss of these animals would have had profound consequences for human populations that had specialized in hunting them, forcing adaptations in subsistence strategies and potentially contributing to population movements and cultural transformations. In the Near East, the Natufian culture, which flourished during the warm period immediately preceding the Younger Dryas, shows evidence of sedentary villages, intensive exploitation of wild grains, and the beginnings of agricultural experimentation. The onset of the Younger Dryas cooling appears to have disrupted this trajectory, with evidence for village abandonment, increased mobility, and potentially population decline. However, the subsequent warm period saw the full development of agriculture and the domestication of plants and animals, suggesting that the stress of the Younger Dryas may have served as a catalyst for these innovations. The idea that agriculture arose partly as a response to the environmental challenges of the Younger Dryas represents one version of the environmental stress hypothesis for agricultural origins, though the precise causal relationships remain complex and contested. The convergence of multiple lines of evidence from ice cores, marine sediments, coral reefs, lake records, flood deposits, and archaeological sites paints a picture of extraordinary environmental instability during the period from 13,000 to 8,000 years ago. This was not a time of gradual, monotonic change, but rather a period of abrupt transitions, catastrophic events, and dramatic reorganization of climate, ecosystems, and human societies. The geological record confirms that massive floods occurred, that sea level rose rapidly and in pulses, that climate could shift with terrifying speed, and that these changes occurred recently enough that human populations were present to experience them. The question is no longer whether catastrophic environmental changes occurred during this period. The evidence for that is overwhelming, but whether the human memory of these events could have been preserved in oral tradition and eventually written down as the flood myths found in cultures around the world. As we conclude this part of our journey into the Great Flood mystery, we like to extend a special thank you for listening. If you're finding comfort in these explorations of deep time and environmental catastrophe, please consider liking this video and subscribing to Slumber Expeditions. We would also love to hear from you in the comments below. Tell us where you're listening from and what time it is there. It's always fascinating to connect with our global community of curious minds. You can also share which part of the story has captivated you the most so far. It would be wonderful to start a conversation around it. Now, let the mystery of what we've uncovered so far settle in your mind as we prepare to continue our exploration. The possibility that advanced civilizations existed prior to the known historical record, only to be destroyed by catastrophic flooding and erased from archaeological memory, has long fascinated researchers operating both within and outside the academic mainstream. This idea suggests that the flood myths preserved in global cultures might not merely represent memories of environmental change, but could instead commemorate the destruction of sophisticated societies whose achievements have been lost to time and the rising seas. While conventional archaeology typically dates the emergence of complex civilization to the period after approximately 6,000 years ago, with the rise of urban centers in Mesopotamia, Egypt, and the Indus Valley, a minority of researchers have argued that this timeline is incomplete and that earlier civilizations may await discovery beneath the waves. The basic logic supporting this possibility is straightforward and difficult to dismiss entirely. If sea level rose by 400 feet from the last glacial maximum to the present, and if coastal zones represented the most favorable habitats for human settlement due to their abundant resources and moderate climates, then it follows that the archaeological record preserved on modern land surfaces is inherently biased toward interior and upland sites. The coastal settlements where human populations were likely most concentrated are now submerged beneath tens or hundreds of feet of seawater, blanketed by marine sediments, and largely inaccessible to conventional archaeological investigation. Any civilizations that emerged in these coastal zones prior to about 8,000 years ago would have been destroyed by rising seas, and their remains would now lie scattered across the continental shelves in locations that are extremely difficult and expensive to survey systematically. This submerged civilization hypothesis has been championed most prominently by writer Graham Hancock, whose books including Fingerprints of the Gods and Underworld have popularized the idea of a lost global civilization destroyed by cataclysmic flooding at the end of the last ice age. Hancock has pointed to the existence of numerous underwater structures discovered in various locations around the world, offshore rock formations, apparent megalithic constructions, and geometric stone arrangements that he interprets as evidence of sophisticated prehistoric architecture. He has also drawn attention to the astronomical alignments supposedly encoded in ancient monuments, interpreting these as evidence of advanced scientific knowledge possessed by a lost civilization that he suggests may have reached levels of sophistication rivaling or exceeding modern societies in certain domains. The academic archaeological community has generally rejected Hancock's thesis, viewing it as lacking in rigorous evidence and relying too heavily on speculative interpretation of ambiguous features. Critics argue that Hancock cherry-picks evidence that supports his hypothesis while ignoring contradictory data, that he misinterprets natural geological formations as artificial structures, and that he attributes to ancient peoples capabilities for which there is no supporting archaeological evidence. The mainstream view holds that the development of complex civilization was a gradual process that can be traced through the archaeological record, that there is no evidence for the kind of sudden emergence of advanced knowledge that Hancock's hypothesis would require, and that the structures he identifies as evidence of lost civilizations are either natural formations or much more recent constructions whose dating has been misunderstood. Yet despite this academic skepticism, the discovery of genuine underwater archaeological sites has demonstrated that substantial prehistoric settlements do indeed exist beneath the waves, and that at least some of these sites preserve evidence of relatively sophisticated cultural practices. The site of At Yem off the coast of Israel, discussed earlier, represents one well-documented example. But there are others that push the boundaries of what archaeology typically expects to find in such contexts. Off the coast of Japan, the Yonaguni monument has generated sustained controversy since its discovery in the 1980s. This large underwater rock formation, featuring geometric terraces, flat plains, and right-angle corners, has been interpreted by some researchers as an artificial structure potentially dating back to the terminal Pleistocene when the site would have been above water. Marine geologist Masaaki Kimura has long argued that the Yonaguni formation shows evidence of human modification and may represent a massive architectural complex submerged when sea levels rose. However, most geologists who have examined the Yonaguni site conclude that it is a natural formation created by the regular fracturing patterns of the local sandstone bedrock combined with wave erosion and tectonic activity. They point out that similar geometric patterns can be found in sandstone formations elsewhere, and that none of the features at Yonaguni unambiguously require human agency to explain. The lack of tool marks, the absence of any associated artifacts, and the presence of similar geometric formations in nearby locations that remain above water all argue against the artificial hypothesis. Nevertheless, the debate continues, with some researchers suggesting that even if the basic structure is natural, humans might have modified or utilized the site for ceremonial or practical purposes during periods when it was accessible. A similar controversy surrounds the underwater structures discovered in the Gulf of Khambhat, formerly Gulf of Cambay, off the western coast of India. In the early 2000s, marine surveys using side-scan sonar identified what appeared to be extensive geometric patterns on the seafloor, interpreted by some Indian researchers as the remains of a large ancient city. Artifacts recovered from the area, including pieces of worked wood and pottery, were subjected to radiocarbon dating and reportedly yielded ages of up to 9,500 years, suggesting a Neolithic or even Mesolithic occupation far earlier than expected for this region. If confirmed, these dates would represent some of the earliest evidence for settled communities in South Asia and would push back the timeline for cultural development in the Indian subcontinent by several millennia. However, the Gulf of Khambhat findings have been received with considerable skepticism by the broader archaeological community. Critics have pointed out that the radiocarbon dates were obtained from isolated artifacts that might have been redeposited by river currents from older contexts, that the sonar images are ambiguous and could represent natural features or modern debris, and that systematic underwater excavation has not been conducted to verify the interpretation of the site as an ancient city. The Gulf of Khambhat is fed by several major rivers that carry enormous quantities of sediment, making underwater visibility extremely poor and archaeological investigation exceptionally challenging. Until more rigorous investigation with direct visual documentation and controlled excavation can be undertaken, the status of the purported underwater city remains unresolved. The Black Sea has yielded more convincing evidence of submerged prehistoric landscapes, including what may be the oldest intact human settlements ever discovered underwater. In the late 1990s and early 2000s, a team led by Robert Ballard, famous for his discovery of the wreck of the Titanic, conducted systematic surveys of the Black Sea floor and discovered remarkable evidence of the ancient submerged coastline, at depths corresponding to the lower Black Sea level that prevailed prior to approximately 7,600 years ago. The team found ancient beaches, river channels, and what appeared to be structural remains including worked timbers and stone foundations. The preservation of these features was extraordinary due to the anoxic conditions below 150 meters depth in the Black Sea, where the absence of oxygen prevents the action of wood-boring organisms and retards decomposition of organic materials. One site, located off the coast of Bulgaria at a depth of approximately 300 feet, appeared to show evidence of a substantial wooden structure, possibly a house or similar building, preserved in the sediments. Radiocarbon dating of the timbers yielded ages consistent with Neolithic occupation, supporting the interpretation that this represented a genuine human structure that had been occupied prior to the flooding of the Black Sea basin. If the catastrophic flood hypothesis for the Black Sea is correct, then this structure and others like it would represent settlements that were suddenly inundated when the barrier of the Bosporus was breached and Mediterranean waters rushed into the basin. The inhabitants would have had to flee rapidly before the advancing waters, perhaps taking only what they could carry and leaving behind their homes and most of their possessions. These refugees, carrying memories of their drowned homeland, might well have been the source of flood traditions that eventually found their way into the mythology of the Near East. The Mediterranean Sea has also yielded evidence of submerged prehistoric sites, though these tend to be less ancient than those in the Black Sea due to the different history of sea level change in the region. Off the coast of Greece, archaeologists have discovered submerged settlements from the Bronze Age, including the remarkable site of Pavlopetri, a complete town layout preserved beneath the waves. Dating to approximately 5,000 years ago, Pavlopetri is too recent to be relevant to the terminal Pleistocene floods, but it demonstrates the principle that coastal settlements can be preserved underwater and can yield valuable archaeological information. More relevant to the earlier period are caves and rock shelters along the Mediterranean coasts that were occupied by hunter-gatherers when sea level is lower and that were subsequently drowned as the seas rose. These sites, now accessible only to divers, preserve evidence of Paleolithic and Mesolithic occupation and document the adaptation of coastal populations to rising sea levels. Perhaps the most intriguing suggestions of very early underwater structures come from the continental shelves off the Americas, where several anomalous features have been reported but remain poorly investigated. Off the coast of Cuba, sonar surveys conducted in the early 2000s identified what appeared to be large geometric structures on the seafloor at depths of over 2,000 feet. The interpretation of these features as artificial structures would imply an age predating the last major rise in sea level, potentially making them many thousands of years old. However, skepticism about these findings is warranted given the depth of the features, the difficulty of determining their nature without direct visual inspection, and the lack of any supporting archaeological context. Natural geological processes can create geometric patterns that superficially resemble artificial structures, and extraordinary claims require extraordinary evidence. The challenge facing researchers interested in searching for submerged prehistoric sites is fundamentally one of scale and methodology. The continental shelves contain millions of square kilometers of submerged landscape, much of it now buried beneath layers of marine sediment deposited over thousands of years. Systematic survey of these vast areas is prohibitively expensive and time-consuming with current technology. Most underwater archaeological work necessarily focuses on known site locations identified through historical records or chance discoveries by divers or fishermen. The probability of randomly encountering a prehistoric site through blind survey is extremely low, meaning that potentially important sites could exist undiscovered across the continental shelves with little hope of being found in the near future. Recent technological advances offer some hope for improving this situation. Multi-beam sonar systems can now map large areas of seafloor with high resolution, identifying features that warrant closer investigation. Autonomous underwater vehicles equipped with cameras and sensors can systematically survey areas that would be too deep or too dangerous for human divers. Remotely operated vehicles allow researchers to conduct visual inspections and even limited excavation work at depth. Machine learning algorithms trained on patterns characteristic of archaeological sites could potentially assist in identifying likely locations from sonar data. These technologies are beginning to be applied to the search for submerged prehistoric sites, but progress remains slow and resources limited. Even if extensive underwater sites from the terminal Pleistocene were to be discovered, interpreting them would present significant challenges. The archaeological record from this period on dry land shows hunter-gatherer societies with varying degrees of sedentism and social complexity, but nothing that would fit the conventional definition of civilization involving cities, monumental architecture, writing systems, and hierarchical social organization. If underwater sites revealed evidence of more complex societies than previously known from this period, it would require reassessment of models of cultural evolution and would raise questions about why such complexity developed in coastal zones, but apparently not in inland areas. The absence of any clearly recognizable architectural remains or artifacts from a supposed lost civilization in terrestrial contexts dating to this period argues against a more extreme versions of the submerged civilization hypothesis. A more modest and defensible version of the hypothesis holds that coastal adaptations during the late Pleistocene may have been more sophisticated than the terrestrial archaeological record suggests, that substantial populations lived in now submerged coastal zones, and that the flooding of these areas would have disrupted established societies and forced migrations that contributed to cultural changes visible in the archaeological record. This version does not require positing advanced civilizations with capabilities exceeding those of known ancient societies, but it does suggest that our picture of late Pleistocene human society is incomplete due to the submergence of the coastal archaeological record. This more conservative hypothesis is compatible with known evidence and helps explain both the global distribution of flood myths and certain puzzles in the archaeological record, such as the relatively rapid appearance of agricultural societies in the Near East shortly after the end of the Younger Dryas. The treatment of indigenous oral traditions as potential sources of historical information represents one of the most significant recent shifts in how researchers approach the distant past. For much of the history of Western scholarship, indigenous myths and legends were dismissed as mere folklore, imaginative stories with no basis in fact, products of pre-scientific thinking that could safely be ignored by serious investigators seeking to understand human history. This dismissive attitude reflected both the general prejudices of colonial and post-colonial scholarship and a specific skepticism about the ability of oral tradition to preserve accurate information over long time periods. If information not written down degrades rapidly through repeated transmission, the thinking went, then stories passed orally through hundreds of generations could not possibly retain factual content from their origins. This attitude has undergone dramatic revision in recent decades as researchers have systematically tested the accuracy of indigenous oral traditions against independent evidence and found that, in many cases, the traditional stories preserve genuine historical and geographical information with remarkable fidelity. The work of geographer Patrick Nunn and linguist Nicholas Reid with Aboriginal Australian flood traditions represents a particularly compelling example of this vindication of oral tradition. By comparing traditional Aboriginal stories about coastal flooding, changes in island topography, and the drowning of formerly accessible land with geological reconstructions of sea level change and coastal evolution, they found strong concordance between the oral traditions and the scientific evidence, suggesting that some Aboriginal stories preserve accurate memories of events that occurred 10,000 years ago or more. One particularly striking example comes from the traditions of the Tiwi people, who inhabit the islands north of Darwin in northern Australia. Tiwi stories describe a time when their islands were connected to the mainland, allowing people to walk across, and tell of the subsequent formation of the water passages that now separate the islands. Geological evidence confirms that the Tiwi Islands were indeed connected to the Australian mainland during periods of lower sea level and became separated approximately 8,000 years ago, when rising seas filled the channels between them. The topographic accuracy of the Tiwi tradition, which correctly identifies areas that were formerly land bridges, argues strongly for its basis in genuine memory of the actual geographical transformation rather than mere imaginative storytelling or coincidence. Similar examples can be drawn from Aboriginal traditions across northern and southeastern Australia. Stories from Spencer Gulf in South Australia describe when the Gulf was dry land that could be walked across, matching geological evidence that this area was exposed during lower sea level stands. Traditions from Port Phillip Bay describe the bay as a hunting ground before waters flooded in, consistent with the actual history of the bay's formation approximately 8,000 to 10,000 years ago. Stories from the Great Barrier Reef region describe walking to reefs and islands that are now separated by water. In each case, the traditional narratives preserve topographically accurate information about landscapes that were transformed by post-glacial sea level rise, suggesting that these traditions have been faithfully transmitted across hundreds of generations. The mechanism by which such accurate transmission occurs appears to involve the embedding of factual information within narratives that are regularly performed in ceremonial contexts, taught to initiates as part of their cultural education, and subject to correction by elders who have responsibility for maintaining the accuracy of traditional knowledge. The stories are not merely entertainment, but serve as repositories of vital environmental information, territorial boundaries, resource locations, and historical events that have ongoing significance for community identity and land tenure. This functional importance creates strong selective pressure for accurate transmission, as errors could have practical consequences for resource management and social relations. The stories are also often linked to specific landscape features, creating mnemonic associations that help preserve accurate geographical details. This recognition of the potential accuracy of long-term oral tradition has profound implications for interpreting flood myths from other cultures. If Aboriginal Australians maintained accurate memories of coastal changes over 10,000 years, might not other coastal peoples have done the same? The flood narratives discussed earlier, from Mesopotamia, the Near East, the Americas, Polynesia, and elsewhere, might represent not merely imaginative myth-making but genuine cultural memories of catastrophic inundation events that affected ancestral populations. The challenge lies in distinguishing stories that encode genuine historical memory from those that are purely symbolic, allegorical, or imaginative, and in determining what historical events, if any, lie behind narratives that have been embellished, transformed, and reinterpreted over long transmission. The Native American traditions regarding floods and catastrophes present particular interest given their diversity and the relatively recent dates at which many were recorded. Among the Ojibwe people of the Great Lakes region, traditional stories describe a great flood from which the culture hero Wainabusu survived by floating on a log with various animals, eventually sending animals to dive beneath the waters to bring up earth from which the new world was created. This narrative has clear parallels with Noah's Ark and the Mesopotamian flood stories, but was recorded from peoples who had no known contact with Near Eastern traditions prior to European colonization. Either the story was independently generated, the similarities represent common psychological patterns, or the tradition preserves memory of an actual flood event that affected the region's inhabitants in the distant past. The Pacific Northwest cultures preserve detailed flood traditions that may relate to specific geological events in that region. Traditions from multiple tribes describe enormous floods associated with battles between supernatural forces, waters rising to mountaintops, and the transformation of landscapes. Some researchers have suggested these traditions might preserve memories of enormous floods that occurred when glacial Lake Missoula burst through its ice dam and sent catastrophic floods down the Columbia River Gorge, an event that occurred multiple times during deglaciation. Other traditions might relate to great tsunamis that struck the coast following massive earthquakes, events that are well documented in the geological record for this tectonically active region and that have recurred throughout the Holocene period. The correlation between indigenous flood traditions and evidence for actual past earthquakes and tsunamis has been convincingly demonstrated for the Cascadia subduction zone, which lies offshore from Northern California, Oregon, Washington, and British Columbia. This fault system generates massive earthquakes approximately every 500 years, most recently in January 1700. Numerous indigenous traditions from coastal tribes describe enormous earthquakes followed by devastating waves that destroyed villages and drowned people, events that native oral historians insisted were not myths but actual historical occurrences. When geologists began studying the geological evidence for past megathrust earthquakes in the region, they found that the indigenous traditions accurately described the characteristics and effects of these events. The 1700 earthquake, which can be precisely dated through documentary records from Japan, where the resulting tsunami was recorded, matches indigenous traditions with striking accuracy, vindicating the historical validity of the oral traditions. This successful correlation of oral tradition with geological and historical evidence has encouraged researchers to take indigenous flood stories more seriously as potential sources of information about past environmental events. However, it also highlights the challenges involved in interpreting these traditions. Not all flood stories can be easily linked to specific events. Many appear to describe repeated or archetypal floods rather than single catastrophes, and the symbolic and cosmological dimensions of the narratives can obscure or complicate their relationship to historical events. Determining which elements of a traditional story represent accurate historical memory and which represent later elaboration, symbolic interpretation, or incorporation of elements from other traditions requires careful analysis and, ideally, independent corroborating evidence from geological or archaeological sources. The Hawaiian tradition provides an illuminating case study in the complexity of interpreting flood myths. Hawaiian stories describe the hero Nuyu building a great vessel to survive a flood sent by the god Cain, in a narrative that superficially resembles the Noah story. However, the Hawaiian tradition includes details specific to Hawaiian culture and mythology, such as the god Cain being associated with freshwater sources and Nuyu making offerings to the moon after the flood. Some researchers have suggested this story might preserve memory of devastating tsunamis that struck the Hawaiian Islands, events that would have appeared to survivors as waves rising from the sea to inundate the land. The geological record confirms that enormous tsunamis, some generated by massive underwater landslides from the flanks of the Hawaiian volcanoes themselves, have repeatedly struck the islands over the past 100,000 years. The most recent major event occurred approximately 500 years ago, within the span of traditional Hawaiian history, making it plausible that memories of such events could have been woven into the flood narratives. The Polynesian expansion across the Pacific, one of humanity's greatest feats of navigation and colonization, occurred during a period of relative sea level stability in the Holocene, but the ancestral Polynesian populations likely carried with them flood traditions derived from earlier experiences in Southeast Asia and Melanesia, regions where dramatic sea level changes during deglaciation would have affected coastal populations. As Polynesian voyagers settled new islands across the Pacific, they would have adapted their traditional stories to new contexts while potentially retaining core elements from their ancestral homeland traditions. The flood stories found across Polynesia might therefore represent a complex layering of memories from different times and places, combined with observations of local phenomena such as tsunamis and storm surges, all woven together into mythological narratives that serve both explanatory and cultural identity functions. The Andean civilizations of South America preserved flood traditions that were recorded by Spanish chroniclers in the 16th century, providing a relatively early documentation of these narratives before extensive European influence could contaminate them. The Inca origin tradition describes how the creator god Viracocha emerged from Lake Titicaca after a great flood had destroyed the previous world, creating the sun, moon, and stars, and then fashioning the first people from clay at Tiwanaku. Other Andean flood stories describe how some people survived by climbing to the tops of high mountains, where they found refuge above the rising waters. The archaeological site of Tiwanaku, near Lake Titicaca, shows evidence of occupation going back thousands of years, and the lake itself has fluctuated dramatically in level during the Holocene in response to changes in precipitation patterns driven by broader climate shifts. While Lake Titicaca is far from the ocean and wouldn't have been directly affected by sea level rise, regional climate changes during the terminal Pleistocene and early Holocene would have caused dramatic changes in lake levels and water availability, potentially generating conditions that inhabitants would have experienced as catastrophic flooding or drought. Amazon basin flood traditions take on particular interest, given recent discoveries that challenge conventional views of Amazonian prehistory. Long considered a counterfeit paradise, incapable of supporting large populations, the Amazon is now recognized to have sustained substantial pre-Columbian populations and considerable landscape modification, including earthwork construction, forest management, and the creation of the anthropogenic soils known as terra preta. Several indigenous Amazonian groups preserve traditions of great floods, often cyclical in nature, destroying previous worlds or eras. Given that the Amazon basin itself is subject to enormous seasonal flooding as tributaries feed into the main river system, it might be argued that these flood traditions merely reflect regular experience with inundation rather than memories of any particular catastrophic event. However, climate records indicate that precipitation patterns in Amazonia changed dramatically during the terminal Pleistocene and early Holocene, with some periods experiencing much higher or lower rainfall than present, potentially generating flood or drought conditions well outside the range of regular seasonal variation. The relationship between cosmic events and terrestrial flooding may seem tenuous at first consideration, yet the mechanics of how extraterrestrial impacts could trigger catastrophic inundation deserve careful examination. An asteroid or comet striking Earth does not merely create a crater at the point of impact. Depending on where and how it strikes, such an event can set in motion cascading consequences that include massive floods, tsunamis, and rapid climate changes that themselves produce further flooding. Understanding these mechanisms helps clarify whether cosmic impacts could plausibly contribute to the flood events preserved in human mythology, and whether the global pattern of flood traditions might encode memories not only of rising seas, but of the violent cosmic events that may have accelerated or triggered those rises. The most direct mechanism by which a cosmic impact could cause flooding involves an object striking the ocean. Approximately 70% of Earth's surface is covered by water, making ocean impacts statistically more likely than land impacts for any randomly arriving asteroid or comet. When a large extraterrestrial object strikes the ocean at velocities of tens of kilometers per second, the kinetic energy released vaporizes the impactor and excavates an enormous cavity in the water, displacing millions or billions of tons of seawater upward and outward. The cavity collapses, generating waves that propagate outward in all directions, tsunamis of extraordinary magnitude that can cross entire ocean basins and strike distant coastlines with devastating force. The size of these impact-generated tsunamis depends on the size and velocity of the impactor, the depth of water at the impact site, and the distance to affected coastlines, but modeling suggests that even relatively modest impacts could generate waves hundreds of feet high striking shores thousands of miles away. Unlike earthquake-generated tsunamis, which typically involve a single primary wave followed by diminishing secondary waves, impact-generated tsunamis could involve multiple wave trains as the displaced water sloshes back and forth in the impact basin. Coastal populations experiencing such an event would witness repeated inundations, with waters advancing far inland, receding, then returning again in cycles that could continue for hours or even days. The trauma of such repeated flooding, combined with the unprecedented scale of inundation, would create exactly the kind of cultural memory that might be preserved as stories of the Great Deluge. If an ocean impact occurred during the period of rapid post-glacial sea level rise, when coastlines were already under stress and populations were being forced to relocate inland, the impact-generated tsunami would compound an already desperate situation, potentially serving as the trigger event that transformed a gradual crisis into an acute catastrophe seared into cultural memory. The possibility of impacts or airbursts over ice sheets presents another mechanism connecting cosmic events to flooding. During the terminal Pleistocene, vast ice sheets covering North America, Scandinavia, and other northern regions contained enormous volumes of frozen water, the equivalent of hundreds of feet of global sea level locked up in continental ice. An impact or a low-altitude airburst over these ice sheets would release tremendous thermal energy, capable of rapidly melting surface ice and creating enormous volumes of meltwater in a geological instant. This meltwater would flow from the ice sheet margins as catastrophic floods, rushing down river valleys, ponding in temporary lakes, and eventually reaching the oceans. The scale of such flooding would dwarf any historical flood events, with flows potentially exceeding the combined discharge of all the world's rivers, carving enormous channels through the landscape and drowning everything in their path. The channeled scablands of eastern Washington, carved by the catastrophic draining of glacial Lake Missoula when ice dams failed repeatedly during deglaciation, provide a terrestrial example of the kind of landscape transformation that can result from sudden releases of glacial meltwater. The scablands preserve evidence of water flows reaching hundreds of feet deep, traveling at speeds of up to 80 miles per hour, and carrying house-sized boulders dozens of miles from their source locations. The erosional features visible today, the deeply incised channels, the enormous gravel bars, the areas of stripped bedrock, demonstrate the tremendous power of catastrophic meltwater floods. Now imagine similar or larger floods triggered not by ice dam failure, but by the thermal pulse from a cosmic airburst melting surface ice across thousands of square kilometers of ice sheet. The resulting floods would have been among the most dramatic events witnessed by Pleistocene humans, creating conditions that would inevitably enter cultural memory as stories of world-destroying deluges. The fragmentation of comets as they approach the inner solar system creates the possibility of multiple impacts or airbursts occurring within a relatively short time period, years, decades, or centuries rather than isolated single events separated by millennia. Comets are structurally weak bodies, composed of ice and dust loosely aggregated with little internal strength. As they approach the Sun and experience increasing solar heating and tidal forces, they can break apart into multiple fragments, each following similar orbits, but spreading out along the orbital path. If Earth intersects such a debris stream, the result could be a series of impacts or airbursts spread over time, producing repeated catastrophes that would seem to any human observers like a sustained cosmic assault. This scenario provides a potential explanation for flood traditions that describe not a single deluge, but multiple catastrophes, or floods that occur in stages over extended periods. The Taurid meteor stream, Earth's passage through which produces the annual Taurid meteor showers in November, has been proposed as potentially containing larger fragments derived from the breakup of a giant comet within the past 20 to 30,000 years. Astronomers have identified several large near-Earth asteroids with orbits similar to the Taurid stream, suggesting they may be remnant fragments of this parent body. The hypothesis that Earth encountered particularly dense concentrations of Taurid debris during the terminal Pleistocene, potentially including fragments large enough to produce significant airbursts or impacts, has been advanced as an explanation for the evidence of cosmic material and widespread burning at the Younger Dryas boundary. While this hypothesis remains controversial and debated, it illustrates how comet fragmentation could produce conditions where multiple cosmic events affect Earth within a geologically short time period, creating a prolonged episode of cosmic bombardment that could contribute to environmental catastrophe and cultural trauma. The detection of impact craters dating to the terminal Pleistocene or early Holocene would provide the most direct evidence that cosmic impacts contributed to the floods of this period. However, identifying such craters faces multiple challenges. Impacts occurring on ice sheets would not produce permanent craters, as the ice would subsequently melt and flow, erasing any structural signature. Ocean impacts would create craters on the seafloor that would be difficult to distinguish from other seafloor features without detailed surveying and that might be buried under subsequent sediment deposition. Even land impacts could be obscured by vegetation, erosion, or human activity over the past 12,000 years. The crater record is inherently incomplete, particularly for smaller impacts and for recent geological time, when crater preservation, may be less reliable than for ancient, well-established features. Despite these challenges, several candidate impact structures have been proposed as potentially dating to the relevant time period. The Burckle crater, a possible impact structure approximately 25 kilometers in diameter located in the Indian Ocean southeast of Madagascar, has been tentatively dated to approximately 2800 to 3000 BCE based on the stratigraphic position of the structure and the age of sediments above it. If this identification and dating are correct, the impact would have occurred during the Bronze Age and would have generated enormous tsunamis affecting coastlines throughout the Indian Ocean basin, including the Arabian Peninsula, East Africa, India, and Southeast Asia. Such an event would have affected numerous early civilizations and could plausibly have contributed to flood traditions in these regions. However, the identification of Burckle as an impact crater remains controversial, with some researchers questioning whether the feature is genuinely an impact structure or might instead represent a volcanic caldera or other geological feature. The possibility of undiscovered impact craters on the continental shelves, now submerged beneath shallow seas, deserves consideration. During the last glacial maximum and the subsequent period of sea level rise, large areas of continental shelf were exposed as dry land, providing potential impact targets that are now underwater. Any impacts occurring on these exposed shelves prior to their inundation would have created craters that are now submerged, likely buried under marine sediments, and extremely difficult to detect without systematic geophysical surveying of vast areas of seafloor. The cost and logistical challenges of such surveys have meant that most continental shelf areas remain poorly mapped at the resolution necessary to identify impact structures. Future technological advances and systematic surveying efforts may reveal impact craters from the terminal Pleistocene that could help resolve questions about the role of cosmic events in the catastrophes of this period. The cultural interpretation of cosmic events witnessed by ancient peoples provides another dimension to understanding potential connections between impacts and flood traditions. A population that witnessed a spectacular fireball crossing the sky, followed by a massive explosion or impact, and subsequently experienced catastrophic flooding, would naturally interpret these events as causally connected. From their perspective, the fire from the sky brought the flood, whether through divine punishment, cosmic battle, or the breaking of celestial barriers that held back primordial waters. The mythological elaboration of such events would weave together the cosmic and terrestrial catastrophes into unified narratives that might obscure the actual sequence and relationship of events, but would preserve the association between celestial phenomena and flooding. Disentangling such merged memories to identify separate cosmic and terrestrial events presents enormous challenges for researchers attempting to extract historical information from mythological sources. The global distribution of traditions linking celestial fire to terrestrial catastrophe suggests that witnessed cosmic events may indeed have contributed to catastrophe narratives. Many flood myths include descriptions of fire preceding or accompanying the deluge, lightning and thunder on cosmic scales, stars falling from heaven, the sky itself appearing to burn. While these elements can be interpreted purely symbolically, representing the cosmic significance of the flood or the divine wrath that caused it, they could also encode genuine observations of meteor airbursts, impact events, or extensive wildfires triggered by such events. The combination of fire and flood in these traditions creates a narrative pattern that aligns with what would be expected if cosmic impacts contributed to or triggered catastrophic flooding events, whether through ocean impacts generating tsunamis, ice sheet impacts producing meltwater floods, or impacts triggering climate changes that accelerated sea level rise. The Australian Aboriginal traditions provide particularly intriguing hints of possible cosmic event memories. Some Aboriginal stories describe celestial fire falling to Earth and causing great destruction, events associated with the creation of certain landscape features or with catastrophic changes to the environment. One well-known example comes from the Henbury craters in central Australia, a cluster of impact craters created approximately 4,000 years ago by the atmospheric fragmentation and impact of an iron meteorite. Aboriginal traditions from the area describe fire devils or celestial beings falling from the sky in this location, creating holes in the ground and causing destruction. The correlation between these traditions and the actual impact site provides strong evidence that Aboriginal peoples witnessed this cosmic event and preserved accurate memory of it for at least 4,000 years, demonstrating once again the potential reliability of Indigenous oral traditions when properly understood and interpreted. If Aboriginal Australians maintained accurate memories of a 4,000-year-old impact event, might they not also preserve memories of older cosmic events, perhaps occurring during the terminal Pleistocene when sea levels were rising and coastlines transforming? Some researchers have suggested that certain Aboriginal traditions describing both celestial fire and rising waters might encode memories of witnessed impacts during the period of post-glacial flooding, though establishing such connections with certainty remains extremely difficult given the complexity of traditional narratives and the challenges of dating the events they describe. The possibility remains open and merits continued investigation as researchers work to better understand the full content and meaning of Aboriginal traditions regarding both cosmic events and environmental changes. The distinction between cosmic events that directly cause flooding and those that merely coincide with flooding periods becomes crucial for evaluating the cosmic contribution to the Great Deluge. An ocean impact generating massive tsunamis represents a direct causal connection. The impact creates the flood. An impact or airburst over an ice sheet that triggers rapid melting similarly represents direct causation. However, a cosmic event that occurs during a period when sea level is already rising due to natural deglaciation represents correlation rather than causation. The cosmic event might still have psychological and cultural significance, being interpreted by witnesses as connected to the environmental changes they were experiencing, and might serve as the trigger that transforms gradual awareness of environmental change into acute catastrophe consciousness, but it would not have been the fundamental cause of the flooding. The challenge for researchers is determining which scenario or scenarios best explain the evidence. Did cosmic impacts contribute directly to the flooding through mechanisms such as tsunami generation or accelerated ice melting? Did cosmic events occur coincidentally during the period of natural post-glacial sea level rise, being subsequently woven into flood narratives as explanatory elements? Or are the cosmic elements in flood myths purely symbolic, representing the supernatural significance of the floods rather than encoding any genuine cosmic event memories? Each of these possibilities finds some support in different aspects of the evidence, and the truth may involve all three operating in different contexts and for different traditions. The modern recognition of the ongoing cosmic impact hazard and the development of planetary defense capabilities represent a contemporary response to a threat that ancient peoples could only experience as divine caprice or cosmic fate. Current surveys have catalogued most large near-Earth asteroids that could cause global catastrophe, and none are currently on collision courses with Earth for at least the next century. However, smaller objects capable of regional devastation remain largely uncatalogued, and the possibility of a previously unknown comet arriving from the outer solar system cannot be entirely eliminated. The investment in detection systems, tracking capabilities, and potential deflection technologies reflects modern civilization's attempt to gain some measure of control over a threat that our ancestors could only observe, fear, and memorialize in their catastrophe traditions. The question of whether cosmic impacts played a role in the great floods of 12,000 years ago remains unresolved and may never be definitively answered. The evidence is fragmentary, ambiguous, and open to multiple interpretations. What seems clear is that cosmic impacts capable of producing significant environmental effects do occur on timescales relevant to human cultural history, that ancient peoples did witness and remember such events, and that the mechanisms exist by which impacts could contribute to catastrophic flooding. Whether such events actually occurred during the critical period of terminal Pleistocene environmental transformation, and whether they contributed meaningfully to the floods preserved in human mythology, awaits further research and potentially new discoveries that might clarify these connections. The cosmic connection to the flood mystery adds yet another layer of complexity to an already intricate puzzle. It suggests that we must look not only at terrestrial processes, glacial melting, sea level rise, tectonic events, but also skyward, considering the possibility that visitors from space may have played roles in shaping both the landscape and the cultural memory of catastrophe. The ancient skywatchers who tracked celestial movements and recorded unusual phenomena may have been responding not merely to intellectual curiosity, but to genuine threats from above that their cultures remembered and feared. Their astronomical knowledge and their flood traditions may be more deeply connected than previously recognized, both reflecting humanity's long experience as inhabitants of a planet subject to influences from the broader cosmic environment in which it exists. As we conclude this part of our journey into the Great Flood mystery, we'd like to extend a special thank you for listening. If you're finding comfort in these explorations of ancient memories, cosmic phenomena, and the search for truth in mythology, please consider liking this video and subscribing to Slumber Expeditions. We would also love to hear from you in the comments below. Tell us where you're listening from and what time it is there. It's always fascinating to connect with our global community of curious minds. You can also share which part of the story has captivated you the most so far. It would be wonderful to start a conversation around it. Now, let the mystery of what we've uncovered so far settle in your mind as we prepare to continue our exploration into how these ancient experiences of catastrophe shaped human psychology, cultural memory, and our ongoing relationship with the forces of nature that dwarf our individual existence yet shape our collective destiny. The persistence of flood narratives across cultures and millennia raises profound questions about the nature of cultural memory, the psychology of trauma and disaster, and the ways human minds process and preserve information about catastrophic events. Why do flood stories, among all possible types of catastrophe narratives, appear with such striking frequency in the mythologies of unrelated peoples? What psychological and social processes operate to maintain these stories across hundreds of generations? And what can structure and content of flood myths tell us about how ancient peoples understood and interpreted the dramatic environmental changes they witnessed? The human capacity for storytelling appears to be deeply rooted in our cognitive architecture, emerging early in individual development and appearing to be universal across cultures. Stories serve multiple functions. They transmit information about the world. They encode cultural values and norms. They create shared identity and community cohesion, and they provide frameworks for understanding experience and making sense of events that might otherwise seem chaotic or meaningless. Catastrophe narratives represent a particularly important category of story because they deal with events that threaten the very existence of communities and that demand explanation in terms that allow survivors to comprehend what happened and to imagine the possibility of recovery and continuity. The structure of flood myths reveals several consistent psychological themes that appear to reflect universal human responses to disaster. The motif of divine warning, in which a deity or supernatural force alerts a chosen individual to impending catastrophe, speaks to the human need to see order and purpose in natural events and to believe that virtue or special status might provide protection from disaster. The gathering of animals and preservation of seeds addresses anxieties about survival and continuity, the fear that catastrophe might not merely kill people, but could destroy the very conditions necessary for life to continue. The landing on a mountain peak represents the search for refuge, the high ground that offers safety when lower elevations are inundated. The sending forth of birds to search for dry land captures both the uncertainty that follows catastrophe and the hope that the disaster is not permanent, that recovery and renewal are possible. These narrative elements resonate with actual human experiences of flooding and may derive from observed behaviors during real flood events. People do seek high ground when waters rise. They do attempt to save livestock and food stores. They do look for signs that waters are receding and that safe return to lowlands is possible. The mythological elaboration of these behaviors into stories involving divine intervention, specially chosen survivors, and cosmic significance represents a characteristic human tendency to narrativize experience, to embed practical knowledge within frameworks of meaning that serve to transmit that knowledge reliably, while also providing psychological and cultural functions beyond mere information transfer. The cultural anthropologist Claude Lévi-Strauss suggested that myths serve as intellectual tools by which traditional societies think through fundamental contradictions and ambiguities in their experience of the world. Flood myths might be understood in this framework as attempts to reconcile the contradiction between the earth as stable foundation and the terrifying reality that even the ground beneath our feet, the most seemingly permanent feature of existence, can be transformed or destroyed. The flood represents the ultimate expression of chaos, the dissolution of the boundary between land and water, the return to a primordial state in which the ordered world has not yet emerged from cosmic waters, the survival of a remnant, and the re-establishment of the world after the flood represents the triumph of order over chaos, the resilience of life, and the possibility of new beginnings even after total catastrophe. From a psychological perspective, the persistence of traumatic memories across generations has become a topic of increasing scientific interest. Research on intergenerational transmission of trauma has documented that the descendants of people who experienced catastrophic events, genocides, wars, famines, natural disasters, can carry psychological traces of these events even when they themselves did not directly experience them. The mechanisms by which this transmission occurs appear to involve both cultural processes, including explicit storytelling and implicit modeling of trauma responses, and potentially biological processes involving epigenetic modifications that can affect stress reactivity and other traits. While the latter possibility remains controversial and requires further research, it raises the intriguing question of whether extremely traumatic events might leave biological traces that persist across generations and that could contribute to the tenacity of cultural memories associated with ancient catastrophes. The concept of cultural trauma, developed by sociologist Jeffrey Alexander, provides another framework for understanding how catastrophes become embedded in collective memory. Cultural trauma occurs when a community experiences an event that threatens its existence or identity so profoundly that the event becomes a defining feature of the group's self-understanding. The trauma is not merely the event itself, but this shared interpretation of the event as world-shattering, as marking a break between before and after, as something that must be remembered and commemorated to maintain community identity. Flood myths might represent examples of cultural trauma from the deep past, events so devastating that they became foundational narratives for the communities that survived them, establishing patterns of remembrance that continue to be transmitted even as the specific historical details became obscured by mythological elaboration. The transformation of historical events into myths involves predictable processes of elaboration, distortion, and symbolic enrichment. Events that were experienced as sequential and causally connected may be compressed or rearranged in mythical retellings. Specific individuals or communities may be transformed into archetypal figures representing broader categories. Local or regional events may be projected onto cosmic scales, becoming stories not merely about a river flooding, but about the entire world being inundated. Symbolic and moral dimensions may be added, with the catastrophe being explained as punishment for human failings or as a test of faith and virtue. These transformations do not necessarily negate the historical core of the narrative, but do complicate efforts to extract factual information from mythological accounts. Psychologist Carl Jung proposed that certain mythological motifs represent archetypes, universal patterns of psychological experience that emerge independently in different cultures because they reflect fundamental structures of the human psyche. The flood as symbol of destruction and renewal, the special individual chosen for survival, the preservation of life across catastrophe. These might be understood in Jungian terms as archetypal patterns that would naturally emerge in human storytelling regardless of whether any actual historical flood occurred. From this perspective, the global distribution of flood myths might reflect not shared historical memory, but shared psychological patterns, the universal human confrontation with the reality of death, and the desire for continuity and renewal. However, the Jungian interpretation faces challenges when confronted with the specific details of flood traditions that correspond to actual geographical and geological features. The Aboriginal Australian stories that accurately describe submerged landscapes, the Black Sea traditions that may preserve memory of the Bosporus Breach, the Pacific Northwest accounts of earthquakes and tsunamis that match the geological record. These examples suggest that at least some flood narratives do encode genuine historical memory rather than merely expressing archetypal psychological patterns. The challenge lies in developing criteria for distinguishing myths that preserve historical memory from those that are purely symbolic or archetypal in origin. The role of ritual and ceremonial performance in maintaining the accuracy and continuity of oral traditions provides insight into how flood memories could have been preserved across vast time spans. In many traditional societies, important stories are not merely told casually, but are performed in specific ritual contexts by authorized individuals, with community oversight ensuring accuracy and correcting deviations from established versions. The stories may be linked to physical landscape features, creating mnemonic associations that help preserve topographical details. They may be embedded in song cycles, where rhythm and melody aid memorization, and where the musical structure helps maintain consistency across retellings. They may be taught as part of initiation ceremonies, creating strong emotional associations that reinforce retention and transmission. These cultural technologies of memory, while not infallible, can be remarkably effective at preserving accurate information across many generations. The comparative study of flood traditions reveals interesting patterns in their distribution and characteristics that may reflect different types of underlying events or different modes of cultural transmission. Flood myths from riverine civilizations often emphasize the role of rivers overflowing and tend to include details specific to river flooding, such as the depositing of fertile silt and the seasonal nature of inundations. Flood myths from coastal peoples more often describe the sea rising and the drowning of inhabited lands, with details suggesting sustained sea level rise rather than temporary flooding. Flood myths from regions affected by tsunamis frequently include sudden onset without warning or mention the association of floods with earthquakes. These variations suggest that different traditions may indeed preserve memories of different types of flooding events, all subsumed under the broader category of deluge myths, but encoding information about specific historical circumstances. The question of how much detail can be reliably preserved in oral tradition over many generations has been addressed through experimental studies and analysis of well-documented cases of tradition transmission. These studies suggest that the accuracy of oral tradition depends critically on cultural context, the importance assigned to accurate transmission, and the presence of mechanisms for error correction. Under optimal conditions, remarkably accurate transmission is possible over many generations, particularly for information that has practical importance or that is embedded in ritual and ceremonial contexts. Under less favorable conditions, degradation of information occurs relatively rapidly, with details being lost, altered, or supplemented with new material. The flood traditions we observe today likely represent a mix of accurately preserved core memories overlaid with centuries or millennia of elaboration, interpretation, and modification. The role of environmental change in shaping human psychology and culture provides another perspective on flood memories. The dramatic environmental transformations that occurred during the terminal Pleistocene would have confronted human populations with unprecedented challenges requiring adaptation in subsistence strategies, settlement patterns, social organization, and cognitive frameworks for understanding the world. The experience of watching familiar landscapes transform, of being forced to migrate repeatedly as coastlines advanced, of witnessing the extinction of familiar animal species and the appearance of new ones, these experiences would have profoundly shaped how people thought about time, change, stability, and the relationship between humans and the natural world. Flood myths might be understood as one expression of this transformed worldview, stories that attempt to make sense of a world characterized by instability and dramatic change rather than the stable, eternal world that earlier cultures may have assumed. The search for physical evidence of the lost worlds drowned by post-glacial sea level rise has accelerated in recent decades as new technologies have made it feasible to systematically survey and investigate underwater landscapes. This work is revealing that the submerged continental shelves contain a rich archaeological record that fundamentally changes our understanding of late Pleistocene human populations, their adaptations, and their responses to environmental change. The drowned coastlines are not empty wastelands but landscapes that once supported substantial human populations and that preserve evidence of their presence in forms ranging from submerged settlements to modified landscapes to artifacts sealed beneath marine sediments. The methodological challenges of underwater archaeology are considerable and help explain why this field has developed more slowly than terrestrial archaeology. Working underwater requires specialized equipment and training, is limited by factors such as visibility, depth, water temperature, and currents, and is far more expensive than land-based archaeology. The preservation of archaeological materials underwater is variable, with organic materials sometimes preserved beautifully in anaerobic conditions, but at other times destroyed by marine organisms or chemical processes. The burial of sites under layers of marine sediment means that many important sites are not visible on the modern seafloor and can only be detected through geophysical survey techniques that identify buried structures and features. All of these factors combine to make underwater archaeological research technically demanding and resource-intensive. Despite these challenges, underwater archaeology has made remarkable discoveries that are beginning to fill in the missing chapter of human history written on drowned coastlines. Off the coast of British Columbia, underwater surveys have identified dozens of sites representing ancient shorelines, now submerged as much as 100 meters below modern sea level, where artifacts including stone tools have been recovered. These sites demonstrate that the coast of British Columbia has been continuously occupied for at least 14,000 years, with early coastal populations exploiting marine resources and developing maritime technologies far earlier than previously recognized. The evidence suggests that coastal routes may have been as important as interior routes for the initial peopling of the Americas, contradicting older models that envisioned exclusively overland migration through an ice-free corridor. The Baltic Sea has yielded extraordinary evidence of late Mesolithic settlements drowned when the sea broke through into the Baltic Basin approximately 8,000 years ago. The site of Hanö, off the southern coast of Sweden, preserves the remains of a drowned landscape, including what appear to be fish traps, hunting installations, and possibly structural remains. The anaerobic conditions at the bottom of the Baltic Sea have preserved organic materials with exceptional fidelity, allowing recovery of wooden artifacts that would not survive in most terrestrial contexts. Similar preservation has been documented at sites in Denmark, where underwater excavations have revealed complete Mesolithic settlements including house floors, hearths, and extensive artifact assemblages, providing unprecedented detail about coastal adaptations during this period. The Mediterranean Sea contains submerged caves and rock shelters that were occupied during the Paleolithic and Mesolithic periods when sea level is lower, and these sites were accessible from the exposed coastal plain. The Cosquer Cave near Marseille, France, contains remarkable Paleolithic cave paintings that are now accessible only through an entrance tunnel that lies well below modern sea level. The cave was clearly created and decorated when the region was above water, and its subsequent inundation as sea level rose has helped preserve the artwork by sealing the cave from casual access. Similar submerged caves have been documented around the Mediterranean, suggesting that an entire constellation of coastal Paleolithic sites awaits discovery in the drowned landscapes of this sea. The Persian Gulf has been the focus of intensive investigation by archaeologists interested in the possibility that the flooded valley might have been a significant center of early Neolithic development. Survey work has identified numerous sites on the Gulf floor that appear to represent settlement locations based on the topographical positions they occupy and the presence of what may be architectural remains visible in sonar imagery. However, the extreme difficulty of working in the Gulf, with its poor underwater visibility, strong currents, and challenging logistics, has prevented detailed investigation of most of these sites. The few that have been examined through diving surveys have yielded artifacts including pottery and lithics, confirming that human occupation did occur in areas now submerged, but much more work is needed to understand the nature and extent of these settlements. Perhaps the most ambitious project for investigating drowned prehistoric landscapes is the multidisciplinary effort to map and study Doggerland, the vast plain that once connected Britain to continental Europe. Using data from oil and gas industry surveys, fishing trawler records, targeted geophysical surveys, and analysis of dredged materials, researchers have built increasingly detailed reconstructions of the Doggerland landscape, revealing a complex topography of rivers, hills, lakes, and coastal zones. Artifacts recovered from the seafloor, primarily through incidental recovery by fishing vessels, confirm that this landscape was extensively inhabited during the Mesolithic period. The diversity of environments represented in Doggerland, from river valleys to wetlands to coastal zones, suggests that this region may have supported substantial and diverse human populations pursuing a variety of subsistence strategies. The challenge of locating specific archaeological sites within the vast expanse of drowned continental shelf has led to the development of predictive modeling approaches that use information about past environments, resource distributions, and archaeological patterns from terrestrial sites to identify likely locations of submerged settlements. These models incorporate data on ancient topography, proximity to freshwater sources, access to diverse resources, shelter from extreme weather, and other factors known to influence settlement location choices. By identifying high-probability zones, researchers can focus limited survey resources on areas most likely to yield important sites. This approach has proven successful in several regions, leading to the discovery of previously unknown underwater archaeological sites. The application of environmental DNA analysis to marine sediments offers a promising new tool for investigating drowned landscapes. By extracting and sequencing ancient DNA from sediment cores collected from the seafloor, researchers can potentially identify what plants and animals were present in the area at different times in the past revealing how ecosystems changed as sea level rose and environments transitioned from terrestrial to marine. The presence of DNA from domesticated plants or animals could potentially indicate human activity even in the absence of visible archaeological remains. While this technique is still in development and faces challenges related to DNA preservation and contamination, it represents an exciting frontier in underwater archaeological research. The discovery of remarkably preserved footprints and trackways in now submerged coastal sediments provides another dramatic form of evidence for human presence in drowned landscapes. Off the coast of British Columbia, footprints of humans walking along an ancient beach have been documented and dated to approximately 13,000 years ago, providing one of the earliest direct evidences of human presence on the Pacific coast of North America. The footprints, preserved in soft sediments that were subsequently buried and lithified before being exposed again through erosion, offer an intimate connection to the actual individuals who walked this coastline during the terminal Pleistocene. Similar trackways and footprints have been found in intertidal zones in Britain, representing Mesolithic peoples moving across mudflats that are now submerged during high tide. The integration of traditional indigenous knowledge with archaeological investigation has proven valuable in underwater research in several regions. Indigenous communities often preserve detailed knowledge of locations that were significant in their histories, including places that are now underwater. Stories about drowned villages, submerged resource gathering sites, and sacred locations below the waves can provide valuable guidance for where to focus archaeological survey efforts. This integration of traditional knowledge with scientific investigation represents a productive collaboration that benefits both archaeology and indigenous communities seeking to document and protect their heritage. The legal and ethical dimensions of investigating drowned prehistoric sites have become increasingly important as more such sites are discovered and as indigenous communities assert rights to their submerged heritage. Many jurisdictions lack clear legal frameworks for managing underwater archaeological resources that predate historical periods, creating ambiguity about ownership, management responsibilities, and appropriate treatment of discoveries. Indigenous communities argue that submerged sites representing their ancestors should be subject to the same consultation requirements and protections as terrestrial sites, a position increasingly recognized by regulatory authorities. The involvement of indigenous communities in the planning and execution of underwater archaeological research has become standard practice in many regions and has generally proven beneficial for both the quality of research and the relationships between archaeologists and communities. The preservation and management of underwater archaeological sites present unique challenges. Unlike terrestrial sites that can be protected through fencing, signage, or legal designation, underwater sites are vulnerable to disturbance from fishing activities, anchor damage, salvage operations, and looting by recreational divers. Climate change poses additional threats, as changes in ocean temperature, acidity, and currents may affect preservation conditions in ways that are difficult to predict or control. Some jurisdictions have established underwater parks or protected areas that restrict activities around important submerged sites, but enforcement is challenging and resources for monitoring and management are typically limited. The potential for discovering truly ancient civilizations in drowned landscapes, while often sensationalized in popular media, remains extremely speculative. The archaeological record from terrestrial sites dating to the late Pleistocene shows hunter-gatherer societies with varying degrees of complexity, but nothing approaching the urban civilizations with monumental architecture, writing systems, and hierarchical social organization that emerged in the early Holocene. If such civilizations had existed earlier, we would expect to find at least some evidence of their influence in the terrestrial archaeological record, whether in the form of trade goods, ideological influences, or remnant populations. The absence of such evidence argues against the more extreme versions of lost civilization hypotheses. However, the possibility that coastal populations achieved levels of social complexity, maritime technological sophistication, or cultural development greater than currently known from terrestrial sites cannot be entirely dismissed and remains an appropriate subject for continued research. The flood mysteries of the past carry resonance and relevance for our present moment, as humanity once again faces the prospect of dramatic sea level change driven by anthropogenic climate warming. The melting of glacial ice in Greenland and Antarctica, the thermal expansion of warming ocean water, and the potential for accelerated ice sheet collapse create the possibility that future generations will experience their own version of the Great Floods, watching as coastlines that have been stable throughout recorded history begin to advance inland, drowning cities, displacing populations, and forcing adaptations on a scale not seen since the terminal Pleistocene. The ancient flood memories remind us that such transformations are not merely theoretical abstractions, but represent human experiences of loss, trauma, and forced migration that will affect real communities and real lives. Current projections for sea level rise over the coming centuries vary depending on the trajectory of greenhouse gas emissions, the sensitivity of ice sheets to warming, and the complex feedbacks within the climate system. Conservative estimates suggest rises of 1 to 2 meters by the end of the century, while more alarming scenarios invoke the possibility of several meters of rise if major ice sheet collapse occurs. Even the lower end of these projections would have devastating consequences for coastal communities around the world, affecting hundreds of millions of people living in low-elevation coastal zones. Many of the world's major cities, New York, Shanghai, Mumbai, Tokyo, Jakarta, Lagos, Miami, face existential threats from rising seas. Entire island nations, including the Maldives, Tuvalu, and the Marshall Islands, risk complete inundation. The agricultural deltas that feed much of the world's population, including the Mekong, Ganges, Brahmaputra, and Nile deltas, face saltwater intrusion and progressive drowning. The pace of contemporary sea level rise, while extremely rapid by historical standards and accelerating in response to warming, is still measured in millimeters per year rather than the meters per century that characterize the most dramatic pulses of post-glacial rise. This means that contemporary societies, unlike their Pleistocene predecessors, have the possibility of anticipating and preparing for the changes that are coming, of implementing planned adaptation and managed retreat rather than experiencing catastrophic surprise. The existence of modern scientific understanding, technological capabilities, and global communication systems provides tools for response that were unavailable to ancient peoples. Yet the scale of the challenge, the number of people affected, the value of infrastructure at risk, the complexity of coordinating responses across multiple jurisdictions and nations remains unprecedented in human history. The responses to rising seas being implemented or discussed in various jurisdictions range from attempts at protection through engineering works to accommodation strategies that accept periodic flooding while modifying structures and land uses to reduce vulnerability, to retreat strategies that involve abandoning areas that will be repeatedly flooded. Each approach has advantages and limitations. Engineering protection through seawalls, levees, and storm surge barriers can be effective for high-value areas, but is prohibitively expensive for large regions, can have negative environmental consequences, and ultimately faces limits imposed by the magnitude of sea level rise and the energy of storm surges. Accommodation through floating buildings, raised structures, and flood-adapted agriculture can work in certain contexts, but becomes impractical beyond certain levels of inundation. Managed retreat, while perhaps the most sustainable long-term response, faces enormous social, economic, and political obstacles as communities understandably resist abandoning homes, lands, and places of deep cultural significance. The lessons from past episodes of Sea Level Rise suggest several insights relevant to contemporary adaptation planning. First, the archaeological evidence makes clear that human populations have repeatedly demonstrated resilience and adaptability in the face of dramatic environmental change, finding ways to survive and even thrive despite the loss of familiar lands and the need to develop new subsistence strategies and technologies. This resilience should be a source of hope, though it comes with the sobering recognition that adaptation often involves significant suffering, loss, and social disruption. Second, the persistence of cultural memories of ancient floods suggests that the psychological and cultural impacts of losing homeland to rising seas extend far beyond the immediate practical challenges, creating wounds that persist across generations. Planning for sea level rise adaptation needs to account for these deeper dimensions of loss, not merely the economic and infrastructural challenges. Third, the global distribution of ancient flood traditions reminds us that sea level rise is not a localized problem but affects coastlines everywhere, creating a shared human challenge that transcends national boundaries and cultural differences. The response to contemporary sea level rise will necessarily involve international cooperation, sharing of resources and knowledge, and recognition of common humanity in the face of shared threat. The failure to achieve such cooperation could lead to conflicts over habitable land, migration crises as climate refugees seek new homes, and the collapse of international order under the pressure of environmental disruption. The choice between these trajectories, cooperative adaptation versus competitive fragmentation, will shape the future of human civilization. The question of intergenerational justice looms large in discussions of climate change and sea level rise. The flood myths of antiquity were not chosen by the people who experienced them. They were victims of natural processes beyond human control, able only to respond and adapt as best they could. Contemporary sea level rise is fundamentally different in that it results from human choices about energy systems, land use, and consumption patterns. The people who will bear the greatest burden of rising seas, future generations, inhabitants of low-lying nations that contributed minimally to greenhouse gas emissions, vulnerable populations lacking resources for adaptation, are not the primary beneficiaries of the fossil fuel economy that drives climate change. This fundamental injustice creates moral obligations that should shape responses, prioritizing support for the most vulnerable and ensuring that adaptation resources are distributed equitably rather than merely following economic and political power. The possibility that we are in the early stages of what could ultimately be dramatic sea level rise comparable to that of the terminal Pleistocene should not be dismissed. If anthropogenic warming triggers major ice sheet collapse, particularly in West Antarctica where ice sheets rest on bedrock below sea level, the resulting sea level rise could ultimately reach tens of meters over centuries or millennia. Under such a scenario, virtually all current coastal cities would eventually be abandoned, entire nations would disappear, and the map of the world would be redrawn as profoundly as it was during the last deglaciation. The timescales involved would be longer than the terminal Pleistocene transition, potentially allowing more orderly adaptation, but the ultimate magnitude of change could be comparable. Future humans, if they survive and adapt successfully to such transformation, might look back on our era as we now look back on the late Pleistocene, as a time of instability and dramatic change that permanently altered the relationship between humanity and the planet. The study of ancient floods and their preservation in cultural memory carries implications beyond climate adaptation. It speaks to fundamental questions about human identity, our relationship to place and landscape, and the ways we construct meaning from our experiences of loss and change. The flood myths encode a recognition that the world is not fixed and eternal but subject to transformation, that stability is temporary and can be shattered by forces beyond human control or understanding, and yet that life persists, communities rebuild, and continuity somehow emerges from catastrophe. These themes resonate across time, linking us to ancestors who faced their own versions of environmental upheaval and found ways forward despite overwhelming challenges. The modern scientific understanding of climate change and sea level rise provides us with knowledge that ancient peoples lacked: the ability to anticipate future changes, to understand their causes, and potentially to influence their magnitude through collective action. This knowledge carries both empowerment and responsibility. We are not helpless victims of forces we cannot comprehend, yet neither can we claim ignorance of the consequences of our choices. The question is whether we will use this knowledge to chart a course toward managed adaptation and reduced future harm, or whether we will prove unable to overcome the political, economic, and psychological obstacles to coordinated response. The answer will determine whether future generations regard our era as one of wisdom and foresight or of negligence and failure. The search for the truth behind ancient flood myths has led us through geological records, archaeological sites, indigenous traditions, cosmic possibilities, and the psychology of cultural memory. What emerges from this exploration is a picture more complex than simple confirmation or dismissal of the myths. The geological evidence confirms that catastrophic environmental changes occurred during the transition from the Pleistocene to the Holocene, that sea level rose dramatically, that coastlines were transformed, and that human populations experienced these changes and were forced to adapt to them. The persistence of flood traditions across cultures suggests that cultural memory of these events was preserved and transmitted, though overlaid with layers of mythological interpretation and symbolic elaboration. The precise relationship between any specific flood myth and specific historical events remains difficult to establish with certainty, but the general principle that the myths preserve some echo of actual catastrophic flooding experienced by ancestral populations appears increasingly defensible. As the hours grow late and the story of ancient floods begins to settle into your consciousness, like sediment drifting down through still waters, we arrive at a place of contemplation rather than conclusion. The mystery of what really happened 12,000 years ago resists simple resolution, existing in that fertile space between established fact and open question where the most interesting human inquiries tend to dwell. What we can say with confidence is that our ancestors lived through extraordinary times, witnessing transformations of the earth that challenged their understanding and required reserves of resilience that allowed them not merely to survive, but to create the cultural foundations upon which all subsequent civilizations would be built. The stories they told about water rising and worlds ending were not mere fantasies, but attempts to make meaning from experiences that must have seemed impossible, yet were undeniably real. Tonight, as you drift towards sleep, perhaps you will dream of ancient coastlines, of peoples watching the horizon where familiar landmarks once stood, but now only waves remain. Perhaps you will imagine the conversations around fires on higher ground, as elders spoke of the lands below the waters and children tried to comprehend a world already vanishing into memory. These dreams, if they come, connect you across the vast expanse of time to those ancestors who faced the great floods, who carried their memories forward through generations uncounted, and who ensured that we, their distant descendants, would know that once the waters rose and the world was transformed. In remembering their stories, in seeking to understand what they experienced, we honor their resilience and remind ourselves that humanity has always been capable of enduring, adapting, and finding meaning even in the face of catastrophes that seem to threaten everything. The waters that drowned their world also carried their stories forward, like seeds floating on the flood, eventually taking root in every corner of the earth where humans made their homes and told tales of the time when the Great Deluge came. The flood myths speak to something eternal in the human experience, our vulnerability to forces larger than ourselves, our capacity to endure despite overwhelming odds, and our need to find meaning in chaos. They remind us that we are not the first generation to face environmental transformation, nor will we be the last. The difference is that we have the knowledge to understand what is happening and perhaps the wisdom to respond with foresight rather than merely react with fear. The ancient floods were natural events, products of planetary processes beyond human influence. The floods that may come in our future will be, at least in part, consequences of human choices, making our response both a practical challenge and a moral test. As the narrative of the Great Flood mystery draws to a close, we are left not with neat answers, but with deeper questions about memory, meaning, and the relationship between past and present. The drowned landscapes beneath the waves hold secrets still untold, archaeological treasures awaiting discovery by future researchers equipped with technologies we can barely imagine. The oral traditions preserved by Indigenous peoples around the world contain information about the deep past that scholarship is only beginning to appreciate and integrate into historical understanding. The geological record continues to yield new insights as analytical techniques improve and new data sources become available. The story of what happened 12,000 years ago is not finished being written. Indeed, each generation will reinterpret this evidence through the lens of its own experiences and concerns, finding in the ancient floods mirrors of its own challenges and sources of inspiration for its own adaptive efforts. The Great Flood mystery invites us to think about time in scales that exceed individual human lifespans, to recognize ourselves as part of a continuum stretching back to ancestors who lived in worlds vastly different from our own, yet faced challenges that resonate with those we confront today. It asks us to consider what stories we are creating now, what memories we are embedding in our cultures, and what future generations will say about how we responded to our era of environmental transformation. Will they tell stories of our wisdom and foresight, of how we came together to protect the vulnerable and chart a course toward a sustainable relationship with the planet? Or will they tell stories of our failure, of opportunities squandered, and disasters that could have been prevented? The choice, unlike for our Pleistocene ancestors, is partly ours to make. The waters that rose 12,000 years ago have long since found their level, the shoreline stabilized, and the drowned lands settled into their submarine rest. The people who experienced those floods are gone, their bones scattered across continents or resting beneath the seas that claimed their homelands. But their stories remain, carried forward through the generations by the simple yet profound human act of telling and retelling, of ensuring that what was learned is not forgotten, that what was experienced continues to matter. In a world increasingly dominated by written records and digital storage, where information can be preserved with unprecedented fidelity, yet is paradoxically more fragile and temporary than ever before, the persistence of oral traditions across 10,000 years stands as a testament to the power of story, the resilience of culture, and the deep human need to remember. The flood came, the waters rose, the world transformed, and yet humanity endured. This simple truth, encoded in myths and legends across the globe, preserved in geological strata and archaeological remains, carried in the DNA of populations that survived and adapted, represents both a memorial to what was lost and a promise that loss is not the end of the story. After the deluge comes the dove with the olive branch, the appearance of the rainbow, the landing on dry land, and the beginning of the new world. These images of hope and renewal, found in flood traditions from many cultures, speak to the irrepressible human capacity to imagine futures beyond catastrophe, to see in endings the seeds of new beginnings, and to face even the most overwhelming challenges with the belief that somehow, through courage and ingenuity and mutual support, a way forward can be found. As you rest now in the comfort of your present moment, safe from the floods of deep time, may you carry with you the stories of those who came before, who faced the rising waters and did not despair, who preserved their memories and passed them down through generations so that we might know and remember. May their resilience inspire your own, their memories inform your understanding, and their survival remind you that humanity has weathered catastrophes before and can do so again. The Great Flood mystery, neither fully solved nor forever beyond understanding, invites you to contemplate your place in the long arc of human history, to recognize the threads that connect you to ancestors who lived in worlds you can barely imagine, and to consider what you will contribute to the ongoing story of humanity's relationship with this dynamic, beautiful, sometimes terrifying planet we call home. The waters of the ancient floods have receded into time, leaving only their traces in stone and story, in drowned cities beneath the waves and memories preserved in myth. But water continues its eternal cycle, falling as rain, flowing in rivers, rising and falling with the tides, shaping the land and nurturing life as it has since the beginning. Water, the very medium of the great floods, is also the source of life, the element without which existence is impossible. This paradox, that what destroys can also sustain, that what takes away also gives, lies at the heart of the flood mysteries and perhaps at the heart of the human condition itself. We live always in the presence of forces that dwarf us, in a world that was here long before we arrived and will continue long after we are gone. Yet we make our marks, tell our stories, love and create and remember, defying our own insignificance through the simple act of being fully, courageously, persistently human. Let the rhythm of rain on ancient shores lull you now toward rest, the sound of waves breaking on coastlines that exist only in memory, the whisper of wind across waters that rose and fell thousands of years before you were born. Let your breath synchronize with the tides of deep time, inhaling the present moment, exhaling into the vast ocean of history that contains all human experience. You are safe here, held in the present, connected to the past, open to the future. The floods of antiquity cannot touch you now except as stories, as lessons, as reminders that change is the only constant and resilience the only reliable response. Rest now in this knowing, drift into sleep on the gentle currents of story and science, memory and meaning, past and present flowing together like tributaries joining to form the river of human experience that carries us all forward into the unknown future. The great flood came, the world transformed, and humanity remembered. That is the story, simple yet profound, terrible yet ultimately hopeful. From the waters of catastrophe emerged the seeds of renewal, the survivors who would become the ancestors of all peoples now living, carrying their memories encoded in traditions that would span continents and centuries. We are their descendants, inheritors of both their traumas and their triumphs, beneficiaries of their resilience and recipients of their stories. What we do with this inheritance, how we interpret their experiences, what lessons we draw from their struggles, how we apply their hard-won wisdom to our own challenges, will determine not only our own futures, but the stories that future generations will tell about us. Sleep now, with the waters of time flowing gently around you, carrying you forward through the night toward morning, through the present toward the future, through the known toward the mysterious. Let the flood myths sing their ancient lullabies, telling of waters that rose and receded, of worlds that ended and began again, of peoples who faced the unimaginable and survived to tell the tale. You are part of that tale now, a link in the chains stretching from deep past to distant future, a keeper of memories that must not be lost, a participant in the ongoing story of humanity's dance with the planet that birthed us and continues to challenge us. Rest in that knowledge, dream in that context, and wake when morning comes to face whatever floods may come with the courage of ancestors who faced their own deluges and prevailed. The mystery remains, half solved and half hidden, like coastlines glimpsed through morning mist, present but not fully revealed. Perhaps it is better this way, the past maintaining some of its secrets, the stories retaining their power to inspire wonder and contemplation. What matters is not merely whether we can reconstruct every detail of what happened 12,000 years ago, but whether we can hear in those ancient stories something that speaks to our present moment, something that calls us to remember our connections to the deep past and our responsibilities to the far future. The Great Flood mystery teaches us that we are not separate from the Earth's processes, but intimately entangled with them, that our fates are bound to the planet's climate and geology, and that the stories we tell about our experiences become part of the inheritance we leave to those who come after. As consciousness fades and sleep approaches, carrying you down into depths where logic dissolves and dreams take form, let go of the need for certainty and embrace the mystery. The waters of the ancient flood flow through your dreams now, carrying you back to times you never knew but somehow remember, to places you never visited but recognize nonetheless. You are swimming through history itself, diving down through layers of time, touching bottom where the drowned cities rest and the memories are buried, then rising again toward the surface where light filters down and the present moment waits. This is the gift of the flood stories. They take you on journeys through time, connect you to ancestors and descendants alike, remind you that you are part of something larger than your individual life, a participant in the great human story that began in the mists of prehistory and continues into futures we cannot imagine but must prepare for nonetheless. The final words of tonight's exploration drift away like mist over water, leaving only impressions, feelings, questions that will settle into your subconscious and perhaps surface again in unexpected moments. The Great Flood happened in ways we are still discovering and may never fully understand. The memories were preserved in forms both faithful and transformed by peoples who recognized that some experiences must be remembered even at the cost of transforming them into myth. The lessons remain relevant, teaching us about resilience, adaptation, the power of memory, and the eternal dance between stability and change that characterizes existence on this dynamic planet. And the mystery endures, inviting each generation to engage with the evidence, to form new interpretations, to add their voices to the ongoing conversation about what happened when the waters rose and the world was transformed. Good night, traveler through time. May your dreams be filled with the gentle sound of waves on ancient shores, the voices of ancestors telling their stories around fires in the night, the sight of coastlines as they were before the floods came. May you wake with the resilience of those who survived catastrophe, the wisdom to learn from deep history, and the courage to face whatever transformations lie ahead. The Great Flood mystery has been told, at least for tonight. Now let its echoes carry you into sleep, into dreams, into the timeless place where past and present merge and all stories are true and all waters lead home.